we stopped, we were discussing about properties of water, right? Yes or no? What is the last property you saw? Just let me know that alone in your notes. I know we were at properties of water, and I told you one more property was remaining. Okay, we finished latent heat. Okay. Fine then. Then let me write the properties. Just tell me whether you got all this. First, you would have seen about phase change, right? After this phase change, you would have went to differential heating of land and water. Then we would have seen latent heat. Within this bipolar nature, hydrogen bonding, anomalous property. I think this is the set we done. Have you finished all these which I've written on this board? Just tell me that alone. All these? Okay, fine. So I think this property is not done. Let me write that in blue color. Just tell me whether this is done. Super cooled liquid. Did I finish this? Super cooled liquid or super cooled water. Respond for this alone. This one. Okay, fine. So this is the only property which we left that day. So now I'll get the lesson plan today. I just wanted to confirm. So we'll finish super cooled liquid. That's the last property. Then we'll need to understand water in the atmosphere. Okay, so under water in the atmosphere, we have two parts. One is humidity. Today is a very humid day. That's the problem if you have rain. We'll see why. So it was humid, especially here in Chennai. Humidity is something which you experience every day. After humidity, we'll be looking at clouds. And please note, before clouds, I need to teach you something called as adiabatic process. So we'll see what exactly is adiabatic process, and then cloud formation, and then finally precipitation. Is it clear? This should take around 45 minutes to possibly 45 minutes. That's the ideal time. So if you have done with this, then I'm going to take you to human geography. Is it clear? You should not have been expecting this because I don't think I told you clearly. And I will tell you why we are starting with human geography when I showed the lesson plan for human geography. So this is the lesson plan till 4:30. Is it clear? Some fundamentals alone. You won't be seeing everything. Then I'll later build on that. So post 4:30, 5 to 7:30, I'll give the lesson plan later. Get ready, people. First property for today, super cooled water or super cooled liquid. Super cooled water, super cooled liquid. The last property, after which we'll go to water in the atmosphere. See, let me write the meaning of that. You can copy it and then I shall proceed to explain as usual. If water is cooled below 0 degrees Celsius, it will not freeze. It will not freeze if there is no freezing nuclei. If there is no freezing nuclei, full stop. Such water is called supercooled. Such water is called supercooled. It's a bizarre property, I can understand. Okay, because we are talking about below 0 degrees Celsius. Okay, take this down, I'll explain. Fine. Read it again. If water is cooled below 0 degrees Celsius, it will not freeze. Again, I qualified it by using a conditional clause, if condition. If there is no freezing nuclei, such water is called supercooled. Works simple enough. So we need to understand not below 0 degrees Celsius, not this, but something called as freezing nuclei, because it is part of the conditional clause and it is changing the phenomenon. So what exactly is nucleation and why is it essential? Please understand, you can take several materials, especially when you talk about phase changes, very true for crystals. See, whenever you want to move between one state to another, either you can move from solid to liquid, or to gas to liquid, or gas to solid, or liquid to solid, any state you want to move along. See, in basic thermodynamics, if the phase changes, I believe you understand the term phase change, moving from one to another. Phase changes is very, very difficult in pure state. Meaning, like if you're going to take pure water and try to reduce your temperature to 0 degrees Celsius, the water will normally not freeze. Okay, pure water needs some sort of impurities so that it can really bind to initiate the process. You can have pure water, reduce temperatures to -25, -30 degrees Celsius, and still you will not be able to start the freezing process. It may not really become solid. So when does this happen? If you want to facilitate the phase changes much easily at the required temperature, then you should be having impurities. Is it clear? So the process, the impurities are simply called as nuclei. Nuclei. These can be anything. It can be natural or artificial particles, can be a pollen grain, can be road dust, could be anything. It has to be extremely small and not a component which is of the pure state. So please understand, if you use nuclei during phase changes, then that process is called nucleation. Nucleation. It will easily facilitate phase change. Nuclei facilitates phase change. So if some sort of nuclei is going to facilitate freezing, okay, it helps for freezing, you call this as freezing nuclei. If some dust particle or air or anything is going to facilitate condensation, you call this as condensation nuclei. I'm just recollecting this for you. Please understand. Condensation nuclei, you would have talked about this in some other aspect. Under properties of troposphere, I would have told you, aerosols or extremely tiny particles, okay, and they provide condensation nuclei for cloud formation. I think you remember. So same thing with reference to your atmosphere also. You want to convert them, then you need to have certain amount of dust particles, because once you add those nuclei, then it is much easier for particles to bind over the surface, because water is a highly hygroscopic substance. They can easily go and absorb over surfaces. So you provide a surface, they're actually providing the substratum, and in the substratum it is much easier for them to change from one state to another, be it gas to liquid or liquid to solid, anything. You get the meaning? So that is called as condensation or freezing nuclei. I believe the meaning makes sense. Any small particle which will facilitate phase change. Now let me read the definition for you again. I believe I've taken this down. Look at this. If water is cooled below 0 degrees Celsius, it will not freeze if there is no freezing nuclei. That's all. It makes perfect sense. Without nucleation, the process won't be done. If it's pure, it is not going to freeze. So that water, which should be in solid state but is still maintained in liquid state, is called as supercooled water. That's all. Is it clear? So let me show you a very short video, a very short one, just to tell you about supercooled water. The audio is not required. What is more important is what happens in the video. A very short one from a very famous physics channel. I think most of you know this channel. Okay. Veritasium. So let me just play this. The entire video is not required. Even the audio is not required. I've not asked them to enable it. I'm just concerned about the last segment, this one. See, listen carefully. I'll tell you now itself. He's taking the water bottle from the freezer. Okay. Normally, when you place water bottle inside the freezer, what will happen? Water will freeze. It will become ice. And he himself would tell you that. He would tell you he was attempting it for several times to get supercooled water, but he still couldn't get it. So this is a lucky case. Naturally or normally it should freeze because it's very difficult to get pure water until and unless you distill it. It's very, very difficult. So he's saying this is by chance he gets it. Don't tell me I place the same thing, but the bottle turned into ice, whatever is inside the bottle. Is it clear? So the temperature is below 0 degrees Celsius right now. You know the freezer, it's at sub-zero. So it's still in liquid state. You can see the air bubble right here. See what happens. Just hold on. I believe you see the phase change happening immediately. We'll do it one more time. Look for phase change again. That is the process of nucleation. We'll understand what happened. See, very simple. He knows that impurities will be present because he hasn't distilled the water. Only thing is, maybe the water molecules did not have proper surface contact. That's all. So what he essentially does is, if this is my water bottle, he takes the water bottle and then forcefully hits it on the floor, on the counter which is there. So when he hits it on the counter, he's agitating the water molecules. So maybe inside the water bottle, there were dust particles or impurities which were sticking by the nuclei which are concerned. So once you provide that agitation, then automatically water molecules begin to bind and they form an ice particle. Listen, now ice itself is a solid surface. Once you start the nucleation process, that alone would be enough. The molecules which are adjacent to that will keep on binding. It's like starting a nuclear chain reaction where one atom generates 3 and then it generates 9 and just goes on and forth. And the entire segment becomes ice. So the point you need to appreciate here is, if you're going to have a tank of supercooled water, okay, you want to give a very bad birthday present to your friend, take your friend, put your friend inside supercooled water, and you can imagine what will happen. He'll just freeze like this, that's all. He'll be caught up. Because he's the nuclei, he's the solid surface, and water will begin to bind and form ice over him. That's a very bad way to kill him also. Okay, so very interesting concept. This is required for appreciating a form of precipitation called hailstones. That is what we are doing. See, it's an evil idea, evil plan. Don't distill water and don't try this, okay? Please don't do that. And I will be put in prison for abetment to murder. Is it clear? Shall we proceed further? But this geography faculty only gave me the idea. I just implemented on my friend for a birthday party. He passed away. Because if ice is going to grow in irregular shapes, then I don't know what will happen to your friend's body. Is it clear? Yeah, physics is everywhere. Everything is geography because all subjects come under geography. Now going to water in the atmosphere, first topic under that is humidity. Humidity. See, you use the word just humidity, it simply means presence of water vapor in the atmosphere, that's all. When you use the word humid, you're just talking about water vapor in the atmosphere. When you say the air is humid, you mean there is more water vapor in the atmosphere. But humidity can be measured in 3 different types. You have, actually there are 4 waves. There is one more thing called as mixing ratio, but that's more optional oriented, not required for us. 3 types are there: absolute, specific, and relative humidity. I'll write the formula for the first 2. You just copy it, then I'll explain both of them. Absolute humidity. Absolute humidity. So amount of water vapor present in air parcel. Let me write the actual word itself. There are chances you might get confused. Just replace the word amount because we'll be using a unit. I give you the unit. Mass of water vapor present in air parcel divided by volume of air parcel. Volume of air parcel. Number 2, specific humidity. The numerator doesn't change in this case. Mass of water vapor in the concerned air parcel divided by mass of air parcel. So let me give you the units right now. Gram per centimeter cube. This is gram per gram. There is a significance why we are concentrating on units also. Will be essential for understanding which is in use more. That's all. Hold on for a few more seconds. Absolute humidity, mass of water vapor present in air parcel divided by volume of air parcel. Specific humidity is mass of water vapor present in air parcel. Numerator is same in both the cases. Denominator varies. Mass of air parcel. Now to understand this, let's consider an analogy. What I'll do is I'll take a very big bag, possibly go to Wildcraft, buy a very big one. See, picture this now. Let's say that the bag is an air parcel. So first you need to understand what an air parcel is. See, air parcel is a theoretical concept. You are talking about an imaginary space. It can be measured in centimeter cube. For example, this box which I'm imaginarily drawing, this can be an air parcel. An air parcel can be as big as this room, okay, very, very big room, possibly even an auditorium. The only thing is you have that for meteorological calculations. Is it clear? You're talking about a surface area which simply holds air. That is called as air parcel. Smaller, bigger, that's left to your calculations. Now, the thing is, picture the bag as the air parcel. Now, inside the bag, we are going to place different sports balls. Okay, maybe you'll try to place basketball, football, cricket ball, everything. Okay, so each and every ball connotes to one, or it is parallel to one specific element which is present in the atmosphere. Maybe your basketball is nitrogen, maybe your football is oxygen, maybe the cricket ball of our choice is water vapor. Okay, so if you take the bag and if let's say that all the balls are present, and if you want to calculate absolute humidity, this is what you'll do. Listen, numerator says mass of water vapor present in air parcel. And we know that the cricket ball is the water vapor content. So if you want to measure mass, what you do is you weigh the cricket ball. Okay, so that will give you the numerator. Second is volume of air parcel. For volume, what you do? You know that the bag is going to have its capacity, isn't it? Its volume. If it is going to be of cuboidal structure, you multiply L into B into H. So that air parcel's volume you put in the denominator. That's all. Mass measured in grams, volume measured in centimeter cube. Simple. Let's come to the second one. Numerator doesn't change. You already have the data by measuring the weight of the cricket ball. But point is, what about mass of air parcel? See, it's very simple. Air has weight means air is having weight with reference to different components. So what you measure here is technically the weight of each and every molecule in the air parcel. So you take your football, maybe football is your oxygen. Okay, oxygen weight. Take your basketball, nitrogen weights. Cricket ball weights. Okay, because water vapor is part of air parcel. Dust particle weights, carbon dioxide, tennis ball, baseball, everything. So you calculate the mass of all the elements in the air parcel and put them in the denominator. So again, look at the unit right now. Numerator is gram. Denominator is gram. Gram and gram get cancelled, so there is no units. Is it clear? Now let's focus one thing right now. If you are a meteorologist and you're trying to work on something, you want to calculate data, try to verify data, it is advisable that you go for specific humidity calculations. And there is one more thing called as relative humidity calculations. Now, why specific and relative? What is the problem with absolute humidity? The answer lies in the unit. Look carefully. You see, the problem with volume is it can be influenced by, when the measurement can be influenced by both temperature and pressure. If there is going to be high temperature, more heating or cooling, or let's say that there is a high pressure environment or a low pressure environment, definitely your calculations will get affected when it comes to your absolute humidity. So after calculating absolute humidity, you need to look at variations in temperature and pressure and make the necessary adjustments if you want a proper neutralized graph. On the other hand, you look at the specific humidity value, it's mass in the numerator, mass in the denominator. There is no way the other factors will influence. That is why specific humidity is a preferred method of calculation over absolute humidity at any day, any place. Is it clear? So shall we go to relative humidity now? Relative humidity. Relative, as the word says. Okay, so let's move to relative humidity. And relative humidity is much more useful in weather forecasting. We'll see that relative humidity. Okay. amount of water vapor in the air parcel divided by maximum capacity to hold water vapor. The word vapor is severely stressed into 100%. The percentage is important here because percentage is the unit. That's why. Look at it again. Amount of water vapor in the air parcel divided by maximum capacity in the air parcel to hold water vapor. It's pretty easy to understand if you take the water bottle. I'm going to draw an analogy. We're not going to take your bag and your balls. We'll take a simpler one. Let this water bottle be your air parcel. You get the meaning? This water bottle. And instead of water inside this bottle, picture water vapor. Okay, we'll just take the same analogy. Now we take this water bottle, the maximum capacity will be the denominator, possibly 1 liter. So 1000 ml is there. Is it clear? Now look at the numerator right there. Maximum capacity to hold water vapor. We are assuming water vapor is water in this case. Amount of water vapor present in the air parcel. You get the meaning? So right now, just now it was filled. So water is, I've just drunk only a few sips. So water is almost to the top. Is it clear? It's filled almost to the top. So 800 ml. You got the idea? See, listen. Now if you multiply by 100%, what is the value you're going to get? 80%, that's all. Is it clear? You cannot have value beyond 100. It's common sense. Maximum capacity is only 1000 ml. So depending upon how much water vapor capacity is there, your relative humidity value will either increase or decrease. I think it's a simpler analogy to understand, even compared to the bag. Water vapor, air parcel is your bottle. Now, we need to understand something even further. Like, how does the relative humidity vary, and what do you mean by this concept called as 100% relative humidity? See, note that there are certain cases when you experience condensation that you can reach the value of 100% because every bottle has a capacity, isn't it? I can't carry 300 liters in the single water bottle. If I keep on pouring more and more water, after a point of time, the water is going to overflow. Similar to that, every air parcel has a limitation up to which it can hold water in the gaseous state. So the maximum limit is 100%. Okay. So relative humidity equals 100% is the maximum limit up to which the air parcel can hold water vapor. Is it clear? And this condition is called saturation. This condition is called saturation. And the air parcel is said to be saturated, meaning it says if RH is equal to 100%. Now, I'll continue further. The temperature, already written there, the temperature at which saturation is achieved is called dew point temperature. Dew point temperature. Dew point temperature. Okay. Dew point temperature. So there is no unit for specific humidity. No, because there is gram and gram, so they get cancelled. I think the meaning makes sense. See, certain environmental conditions, you might have saturation at 0 degrees. In certain environmental conditions, 5 degrees, certain environments, 10 degrees, certain 15, in certain cases, -5. So dew point temperature varies depending upon where you are, which part of the earth you are actually in. So point is, the temperature at which I reach the maximum limit is called as dew point temperature. Only up to dew point temperature, the water vapor can hold it in the gaseous state. Now, what will essentially happen if you reach dew point temperature, or if you reach beyond that 100%? That is what we're going to understand. Listen here. If dew point temperature is greater than 0 degrees Celsius, dew point temperature is less than 0 degrees Celsius. There are two possible conditions, that's all. That's why I explained further. Dew point temperature can be 5 degrees Celsius, -5, 10, -10, both are possible, different environments. So once they've reached it, there is saturation. Beyond saturation, I cannot hold water in the gaseous state. Is it clear? So once I cannot hold it in gaseous state, from gaseous state, it can either get converted to my liquid state or solid state. That is determined by dew point temperature. If it is greater than 0 degrees Celsius, above freezing, water vapor will get condensation and this will become liquid state. Is it clear? But if the temperature is below freezing, this is a beautiful state, water vapor will directly become solid. So this is your liquid water drop. Liquid water. This is solid ice crystal. Solid ice crystal. So why are we specifying the word ice crystal? Because ice crystal has this hexagonal beautiful shape. Very beautiful. That's your ice crystal. And ice crystal is possible only when there is direct transition from gaseous to solid state. Is it clear? This is what we learned as deposition in the different phase changes. So you reach dew point temperature. Dew point temperature is greater than 0 or less than 0 will determine whether you are moving towards liquid or solid state. Is it clear? Can you give example with comparison with cities like Chennai and Coimbatore? See, let me finish adiabatic process. You'll get the idea. Let me finish adiabatic process. Just take this down. We was like once I explain adiabatic process, it'll be much easier for you to appreciate it. Because this might simply seem as greater than 0, less than 0, not really interesting. We'll see what happens. You will get examples. Please be patient. I believe you've taken down. Okay. So let me teach you adiabatic process, and through adiabatic process, we look at cloud formation. Okay. So cloud formation, and immediately you'll be able to relate to fog formation also. I think that time these meanings will become more clearer. I'll finish that, then I'll possibly take doubts. Okay, so the next one is adiabatic process. Let me put it here itself. Adiabatic process. The mechanical engineers would know. I do not know how many of them are there, but they are everywhere. Okay. Adiabatic process, a process in which there is no heat or mass exchange between the system and its surroundings. System and its surroundings. Okay. A process in which there is no heat or mass exchange between the system and its surroundings. Again, may not make sense. I need to explain. Please be patient. We are just crossing the physics level. Once we go to clouds, you go to human geography, then you'll see the application. See, today I will teach you one climatic condition, and tomorrow when I come to deserts, you'll completely understand why we are stressing on these things. Is it clear? Process in which there is no heat or mass exchange between the system and its surroundings. I need to take some time to lay the fundamentals. Once I've done that, we will breeze through. Listen here. Let's take the same water bottle of our choice. There are two ways, either to increase temperature or decrease temperature. The water bottle in my condition is my system. That is the system of my choice. Okay. Now, the temperature of the system, I can increase or decrease in two ways. Listen carefully. Right now, it is at room temperature, 25 degrees Celsius. If I want to increase the temperature, I'll take this water bottle, my system, and place it over a stove. I start heating, automatically temperature will increase. On the other hand, I feel I need to reduce the temperature to sub-zero, degrees, then I'll just take it to the refrigerator. Fridge. I'll place it inside the refrigerator. I place it inside the fridge, temperature will fall below 25. Listen carefully. Both these cases, there is possibility or allowing heat exchange between my system and the surrounding environment. This is a diabatic process. This is not an adiabatic process. So what exactly is an adiabatic process? Well, in adiabatic process, you don't allow for heat exchange. It is a theoretical. You don't get an extremely, highly complete or highly pure adiabatic process, you don't find it in nature, but you get something close to an adiabatic process. So what should essentially happen is, well, the temperature of bottle should decline, but it shouldn't decline due to heat exchange allowed. If that is not the case, when will it decline? Listen, it's actually a simpler process than you think. See, understand this. I'm standing in this point. Let's say this is point A where I'm standing. So from point A, I move to point B. Point B, I come back to point A. Point A, I move on to point B. Get it? Now, when I'm moving from here and there, you clearly see that I'm working, right? Once I work, I will lose my energy. Okay. Thing is, if energy decline continues over a period of time, my temperature will decrease. Of course, my body will try to maintain the temperature, but I keep on losing energy over a period of time. This is not possible. You take any system, if the system does work, there is reduction in energy. If there is reduction in energy, because of reduction in energy, temperature will decline. Because what is after all energy? Energy is nothing but your kinetic energy of molecules, your heat energy. So naturally, temperature will decline. This is an example of adiabatic process where there is energy change in the system because work is being done either by the system or on the system. That's an adiabatic process. Think back again, I'm working. Because of work, there is reduction in energy. Because of reduction in energy, there is decline in temperature. Okay, no one heated me, no one cooled me. I was simply moving here and there. That itself reduced my temperature. Meaning makes sense. Is this clear? This one? So that's how an adiabatic process works. Not you heat and cool, but due to work, there is change. Now let's try to put it as an example. Listen. This could be any region. Possibly this is Anna Nagar, this one single line. Now in Anna Nagar, there are many air parcels. Let's talk about one air parcel, which is in a localized area of concrete. So many buildings are there. So sunlight is very, very high, and in those buildings, there is high surface temperature. Is it clear? So in this region, the temperature is more. So surface temperature is heating the atmosphere also. So listen, 30 degrees Celsius. Surrounding also atmosphere is there, but there the heat is not very high. Let's say 25. Let me not put a square circle, then you might get confused. Let's say the environment is at 25 degrees Celsius. Surrounding environment is at 25, but I am at 30. I am more hot because the surface area is covered with more buildings. It's much, much hotter. See, it's simple. It's very simple. Air parcels will begin to vertically move up only when they have higher energy, meaning higher temperature when compared to the environment. And this has to happen at every successful height. Is it clear? Think back to your troposphere again. With increase in altitude, there is decrease in temperature. Okay, that is for the environment. So environmental temperature may be 25. Maybe after 1 kilometer or 2 kilometers, it becomes 15. Okay, then it becomes possibly 5. See, just random value is not the perfect one. This is how the environment is losing energy. Okay, just basic example. Let's see what happens. First level, the air parcel is having more energy compared to the environment, which means air parcel will automatically rise up. Meaning makes sense, it moves up. Listen, air parcel, not environment's temperature is not reducing. Air parcel is doing work. Once you do work, you will be using energy. Once energy is lost, then temperature will decrease. So because of work done, we assume an adiabatic process where there is no heat exchange between the air parcel and the surroundings, and the air parcel loses its energy, losing its temperature. Let's say it goes to 20 degrees Celsius. You get the meaning? Now, after 1 to 1.5 kilometers, again, you compare the surrounding environment, still the air parcel is hotter. What will happen? I am more stronger than the environment, I'll still fly like Superman. Assume a condition that for this air parcel, assume the dew point temperature is 10 degrees Celsius. Is it clear? Dew point temperature is 10 degrees Celsius. We've assumed for this environment. Now, when it moves up, again, same condition. Work is done, energy is lost, temperature is lost, temperature becomes 10 degrees Celsius. Is it clear? You see, what will happen? Dew point temperature is at 10 degrees Celsius? No. So at dew point temperature, we just saw saturation is reached. Once saturation is reached, it is not possible for the air parcel to hold water in gaseous state. It needs to either convert to liquid state or solid state. Here, troposphere only, no? Several dust particles will be there. There will be several nuclei. So several nuclei will be there. Air parcels of nuclei will be there. Is it clear? So 10 degrees Celsius is greater than 0. Sorry, I wrote DT here. 10 degrees Celsius is greater than 0. So once it is greater than 0 degrees Celsius, gaseous vapor will get converted to liquid water droplet we saw. Listen. In these nuclei, facilitating phase change, we spend some time. All of them will become, not all of them, slow, it's a very slow process. Slowly they become liquid water droplets. This is only cloud. Now we understand how clouds are forming. Clouds essentially form because air parcels spend a lot of energy. By spending a lot of energy, they keep moving up, and when they reach dew point temperature, there is saturation. Saturation will give rise to clouds in the atmosphere. Does it make sense now how clouds are formed? That's why we spent enough time on that. Is this okay now? Work, energy reduced, temperature reduced, I've reached it. Gobi Jagan, is this clear now? Because you asked me to explain adiabatic process. This is a direct application of how clouds get formed. So if this is clear, then I'll proceed further. Okay, that's why I told you. Don't just wait for it so that you get the relationship based on how things happen. Okay, fine. Shall I move to the next topic? Something like heating of air. Yeah. After you heat, only temperature will be more. This is something like heating of. After heating of air, air is losing energy because it is doing work. It's not just heating of air. Is it clear? So I'll move on further, but this time we'll need to properly structure adiabatic process. There are two ways. Is it clear? Just hold on. Adiabatic expansion then and then adiabatic compression. Those words you'll be having in your book. Let me just clear that. So two possibilities are there. Air parcel is present. This air parcel is using a lot of energy. It is vertically moving up. This is called adiabatic expansion. Adiabatic expansion. Where large number of molecules, they are closely packed in the air parcel. Now they're using energy. They work a lot. Once there is work, there is a reduction in temperature. Is it not? So adiabatic expansion causes cooling effects. Is it clear? Where the molecules are moving, so they expend kinetic energy. They expand. The parcel expand. Please note, particles are not expanding. Parcel expands. Particle expansion I never mentioned. You decrease temperature, particle size will reduce. Air parcel is expanding because they are doing work. Come back to the second case. Just the opposite condition. In this case, there is compression. Is it clear? Compression. Where molecules are forcefully compressed. In this condition, work is not done by the system, but work is done on the system. So this is adiabatic compression. I'll need to write that. Adiabatic compression. Okay, so work is done by the system in this case. Work is done by the system. So since the system is doing work, the air parcel is doing work, it is losing its energy. You take the other case, due to adiabatic compression, work is done on the system. Work is done on the system. On the system. And because of this, temperature is going to increase. Is it clear? So adiabatic compression, always remember, will cause heating. For this one, you need to wait until deserts. Like where exactly adiabatic compression happens, at least till deserts. I'll give you two instances where this process happens naturally. Air passes moving down forcefully. See, I'll give you a simple thematic to remember. It's very, very simple and it's more realistic also. Picture two conditions. One is your cycle tire. You still have difficulty in your cycle tire. One is your friend's cycle tire. Your friend, not yours. Listen. It's very easy to remember. What you do is your cycle, you go, take your pump, put the nozzle properly. After putting your pump, start pumping. Start pumping nicely. Once you started pumping, after possibly, 5 minutes of hard pumping, you go and touch the nozzle for 1 second. It'll be extremely hot. You might possibly get fried fingers. Is it clear? See, please understand, when you compress air over a very, very nano channel, you're providing them with a lot of energy. Adiabatic compression causes heating. Able to understand? Now listen. This is your friend's cycle. What you do is, this is our cycle. Good. This is his cycle. Bad. Open the nozzle. Open money. Throw it away. Is it clear? Once you open the nozzle, stand there. For 2 minutes you stand. Slowly air will expand. Is it clear? It's doing a lot of work. You know how cool it will be for you. Adiabatic expansion causes cooling. Something which we do with cycle tires. Is it clear? Internet disconnected at reduction of temperature. I believe you participated in the adiabatic discussion. At least you got the tire example right. Is it clear? Internet disconnection, one person has said. Yeah, fine. You got it, it should be okay. See, this one I've given you example already. Adiabatic expansion, cooling, cloud formation. They work. Compression, please wait till deserts. Pause today, it's quite difficult, but tomorrow, first 2 o'clock itself, we'll be seeing desert climate. At that time, I'll show you. Okay. So which will help in cloud formation? This process helps in cloud formation. Air passes should move up. Either reverse condition. Compression is there, cloud formation is very, very difficult. Two opposite cases. Expand, compress. Okay. So I'll move to the next topic right now. There is heat exchange. Raj, that's what I told you. We are assuming perfect condition. Listen, but in reality, perfect isolation is not possible. You don't have a boundary like this. There is nothing like that. Air passes, yes, they will try to move outside. But the point is, you can go for an imaginary boundary because vertical movement will be dominant for most air molecules. So you theorize it to be a perfect condition. You theorize 100%, but 100% is not possible. You might get close to 90, 85% of molecules moving up, maybe 15 molecules moving to the side. That is reality. But ideal condition, we assume 100. Is it clear? So there is heat exchange. You're right. There is heat exchange. But we assume that the exchange is very, very feeble and there is more vertical movement, either upward or downward. Okay. Because you never find ideal conditions in nature. No, that's what you learn in mechanical engineering, right? You cannot create a perfect Carnot engine is taken as the example of as close I can get to idealness, but it's not possible. Similar to that, nature also. Is it clear? So I think that clarifies your doubt. We're just assuming theoretical here. It's not, the perfect condition is not possible, but the net relative movement will be towards up. That's the last doubt. I'll proceed further. After adiabatic process, we need to talk about clouds. And before clouds, let me address this question. Someone asked about saturation, isn't it? Let me address this. You need to understand this simple concept. Just know this will be useful later. Okay. So we were talking about relative humidity, right? See, understand, people always misconceive if relative humidity is actually high, then we might be having a large amount of water. That is not true. Please note, I will give you two air parcels. One air parcel is big. One air parcel is very, very small. Got the idea? India maximum capacity itself is less. Now this air parcel you can feed, let's say this is 1000 ml. Example only, I fill it 500 ml. Okay. How much relative humidity? Relative humidity will be 50%. Meaning, Purusada? Now understand, air parcel capacity itself 100 ml only. In this 100 ml, let's say I fill it to the top, 90 ml. 90 ml na in the bottle, not that 90 ml, 100 ml. Is it clear? Relative humidity will be 90%. Is it clear? Listen, In both these cases, you look at relative humidity data, means here it will be 90. Oh, 90%, that much water is there. Please understand, relative humidity will only tell you whether the parcel is going to reach saturation or not, whether you are going to experience condensation, whether you're going to experience deposition. That only it will tell you. It doesn't tell you about how much exact water is. See, only 90 ml is present in this case. But here, in spite of having 500 ml, it's like having 5.5 times more water. But still, relative humidity is only 50%. Why? Because capacity varies. Okay, whether you can drink 1000 ml or whether you can drink 100 ml, capacity varies. You get the meaning? So please note, it's not just about RH. RH can give you about capacity. RH cannot give you the exact value. Meaning makes sense. Now, same air passes, capacity reduces now, then automatically relative humidity will become 100%. Let's say the capacity itself reduces. Capacity is 500 ml, total amount is 500 ml, RH will be 100%. This is clear. So please understand, the fundamental principle is that air passes capacity varies across different environments, and keep this thumb rule with you. Last one. Yeah, before this. With increase in temperature, the air parcel will have more capacity to hold water vapor. Let me just go to the previous one and come back. This is the condition in colder environments. Is it clear? This could be the condition in desert environment. Meaning makes sense? So more temperature, most people think that deserts, water is not there. Water will be there, but problem is you'll never reach saturation. That is the problem. Desert's temperature is too high. Meaning makes sense? Last point for saturation, with increase in temperature, the air passer's capacity to hold water vapor will also increase. It's like you're increasing the size of the water bottle. Okay. Sorry. Shall I move to clouds right now? Clouds, anyone? Tell me whether you're done. Okay, fine. Let's go to clouds right now. And we just need to look at types and classification. See, it's a small topic, but still, it'll be always better if you use pictures. So, presentation doesn't have content as much, but pictures are present where there is orderly arrangement. So, go to that. I haven't seen the film 90 ml. I don't know whether any one of you have seen it. I think it was released 8 months back, 9 months back, maybe sorry, not 8 and 9 months. Lockdown itself, it's 7 months. Life is horrible, man, really. 2020 is not there. It's as if you lost change from your front pocket or someone stole your purse. It just vanished. Now I'm thinking, when did 90 ml release? It was quite a while. Okay, for non-Tamil speakers, 90 ml is not a great film, even if you think it is. So please, no, not necessary to watch and all. Okay. I knew it became controversial just because of the trailer. That's all I remember. Long time back. So first, let's try to define it and understand why exactly clouds float. Basic definition. Okay. Clouds are floating masses of condensed water droplets, condensed water droplets, and ice crystals, floating masses of condensed water droplets and ice crystals. That's all. First thing you need to appreciate is clouds are actually not gases. That is because of the English poets or the Tamil poets. Okay, they always write about clouds there as if some gaseous things are floating. It's not gas. Please understand. Cloud is either water or cloud is either ice. That's all. There is proper visibility. Please don't think clouds as gas. Think back to adiabatic process again. You formed clouds only after reaching saturation. Water from vapor state is either moving to gaseous state or its liquid state. So that exactly is cloud. So second, we need to understand how exactly clouds are floating. I misplaced the picture. Picture is right here. These are condors. Condors are native to the They're American continent. They belong to the New World. North and South America is, very famous over the Andes Mountains. Similar to the vultures are the related species when we talk about the New World. And you would have seen several hawks, kites when you're in a city or a rural area, not really flapping their wings and flying. So condors can fly without flapping their wings, okay, close to 1 hour. For entire 60 minutes, they just need 2 to 3 flaps and they can sustain themselves for a long time. So how exactly do they do that? Well, because they use something which may not be visible to the naked eye. Those are called convection currents. See, note that the heat from the surface of the earth is vertically transferred. The vertical transfer of heat is called as convection. Is it clear? And that convection, I think you all know, it is made possible because of atmosphere's air molecules. So throughout the earth, vertically air molecules move up, may not be visible to the naked eye. Is it clear? So that process is called as convective currents. Convective currents. And why do they move? They move simply to transfer heat vertically, that's all. Wind is advection, that is horizontal transfer of heat. And convective currents is movement of air molecules to facilitate vertical transfer of heat. So this is present all over the earth. The point is, you take clouds, the size of the water droplet in a cloud in an average is extremely less. You take a water drop in a cloud, drop. The diameter is approximately 20 micrometers. Is it clear? You want a comparison, you take the diameter of human hair. Okay, that's like 75 micrometers. You get the difference. A human hair's diameter is 3 times bigger than a water droplet. Just to give you the size criteria of how small an average water droplet is. Basically, so extremely small. So for those type of water droplets, it's much easier. They just receive the convective currents and automatically they will keep floating. So if the cloud is there, cloud might descend. Okay, a huge gust of convective current, again cloud will move up. Descend, again cloud moves up. Descend, it goes on and on. That's how they consistently float in the atmosphere. Is this okay? So clouds get suspended in the atmosphere because of 2 reasons. The size of the water droplet is extremely small, micrometer, microscopic. So it doesn't really have much of weight. Okay. And the second thing is there is vertical movement of convective currents which keeps the clouds afloat. So 2 reasons, smaller size, convective currents. Now moving to the classification system. So if you think about it, it's quite difficult to classify clouds because clouds take innumerable number of shapes. This problem was solved by a Danish meteorologist, Luke Howard, in the year 1803. He came up with an interesting idea. The idea is this. Okay. He stated, see, clouds can have innumerable number of shapes, but there are 3 basic shapes or forms. Based on that, you can classify clouds. And he also said these 3 shapes or forms can give rise to different combinations and they are present in different altitudes. So his idea, which was given in 1803, until then it was a very big headache to anyone who's pursuing climatology, was actually solved with this simple model. He said, see, you can have any type of cloud, you can actually fit them basically in these 3 shapes. You can have several combinations, but the 3 shapes in one way or the other will be prevalent. So first uses the word cirrus. All these 3 words are derived from Latin. Cirrus means, everything is in Latin. Cirrus means curl, hair curl or tendril. Is it clear? So very fine, very fine cloud. Looks like feathers. Is it clear? Second, cumulus. Cumulus means heap in Latin. Heap. So I think you do know. Cumulus. Okay, something which we draw clouds. This is what we draw first. Next, stratus means sheets. Okay. These are stratus clouds. Quite extensive. So cirrus, cumulus, and stratus. So this is the basic three-form shape classification. Now, what I mean by combining different names, you can combine different names, meaning you can have a cirrocumulus. So you take large number of feather-shaped clouds and arrange them into a heap, you will immediately get cirrocumulus. You can also get cirrostratus, cumulostratus. Combinations are possible. That's what I mean by different names of clouds. So use these three shapes, try to combine, you'll immediately get several names of clouds. And he didn't stop here. Apart from these three basic forms, you can also classify them based on your altitude. We'll see altitude right now. So based on altitude, next is the picture, yeah. Based on altitude, you can either classify them as high clouds, middle clouds, or your low clouds. I've given the data already here. 6 kilometers or above, so quite tall. 6 kilometers or above. These clouds are primarily made of ice crystals. The temperature is extremely low, so you get your ice crystals. Got it? Then below 2 kilometers, very close to the surface, you get your low clouds. These are predominantly made of water droplets. Water droplets. Whereas the middle clouds, on the other hand, has a combination of both. You have a good percentage of ice crystals and water droplets together. And water drops together. Okay. Domination of ice crystals in high clouds, domination of water droplets in low clouds. Because again, increase in altitude, decrease in temperature. Here temperature can be quite high comparatively. Middle clouds is a combination of both. See, now we are essentially going to see pictures. Okay, we'll send the PPT. PPT, there is nothing except for the pictures. The point is, there is nothing more to copy right here. I just want you to focus on the different shapes which are present. Let's see where it goes on. Okay, so first we look at high clouds, 4, then middle clouds, then low clouds. There's one type of cloud which doesn't really fit in anything. Okay, that also we will see. Totally there are 10. We'll go one by one. First is your high cloud classification, starting from cirrus. And the picture is fairly visible. Very fine, extremely feather shaped. Okay, so it's natural. These type of fine clouds, if you just give one vertical push, it is enough. Automatically, they'll be floating in high altitudes only. You can clearly see they're not heavy. Okay, second one. This is cirrostratus, second high cloud. Always remember, cirrus clouds will be in the high portion. Their feathers, they're very fine, automatically pushed up. So the point is, these are feathery, but they extend over a large area. I think you can see the enormous amount of length over which they spread over. These are cirrostratus. Stratus is sheets. Think back again. So third combination would be cirrocumulus. You guessed it correct. So we just look at cirrocumulus. You got it, same thing. But you can clearly see they're very transparent, very fine, located in very high altitudes. Got it? So these are your high clouds. And now coming to your middle clouds. Okay, so cirrus, cirrostratus, cirrocumulus. 3 high clouds, all of them with the prefix cirrus. Fine. Coming to your middle cloud, you have 2 types, altostratus and altocumulus. Alto is a name which we need to understand. It's derived from this word altus. Altus means middle, that's all. So you are talking about your stratus cloud, which is not very high, extremely high, but it's present almost in your middle heights. Again, you can get the same idea as you saw with your cirrostratus, quite extensive. Stratus cloud in the middle altitude, altostratus. Next type you should have guessed already. Look at this. Also cumulus. You can see that the number is much more higher compared to your cirrocumulus, isn't it? But now you look at your altocumulus, they become much bigger, extensive area, also cumulus. coming to your low clouds right now. Now, that is your stratus. I think you see a very hazy area where just clouds spread over. That is my stratus. See, listen, I don't think whether you noticed that one very small observation. Okay, let me show you again. In the previous pictures, you would have never seen this one. You see what these, okay, you ask me what this is. This is your house, land, everything is there, all your trees. In the previous pictures, you would not have seen them very intensely. These are actually shot very, very high. You don't have any relation with surface. But once you start coming to your alto clouds, you can at least see the treetop in the picture. Okay, which means they're not very high, but they're still high. You come to your stratus clouds on the other hand, you can see the entire village or town. So these are very close to surface. Just from the way the picture is taken, you can understand. Low cloud, number one, stratus. Second, low cloud, cumulus. You can clearly see the entire tree right here. These are beautiful, isn't it? Cumulus cloud. Explain, they kind of provide you the understanding. See, if you're going to see these clouds in the morning around 11 or 11:30, and they're quite there in large numbers, you can expect very good rainfall in the evening. I'll tell you why. Okay, these are your cumulus clouds. These can develop into something really dramatic. Now we'll go to the rain cloud. This cloud is capable of giving rain. Nimbostratus. I think you would have heard about Nimbus 2000, Harry Potter. Nimbus. Nimbus is your rain cloud. You can clearly see that they are much, much darker, spreading over a very large area, very extensive. Compare this with altocumulus. Hold on, let me show you altocumulus right now. Now this was altocumulus. See, altocumulus might seem darker, but you still find penetration of sunlight. Okay, and the area is not very high. You come to nimbostratus on the other hand, you clearly don't see sunlight and it's extremely extensive. This is my rain cloud. Very low. Okay, the size of the water droplets will be quite big. Got it? And after your rain cloud, the last one is my thunder cloud. This is not a nuclear explosion, but this is a cloud. You get it? So big. So big. These are cumulus clouds, isn't it? This one. These clouds can become like cumulonimbus clouds. Got the understanding? So there is high vertical movement of air that can keep on feeding the cloud, increase more and more cloud formation. This is the cloud responsible for thunder and lightning. Thunder cloud. So nimbostratus was my rain cloud. This cloud cannot be classified either as a low cloud, middle cloud or a high cloud because it is present in every single level. At times, the entire height of the cloud can go up to 10 to 12 kilometers. Very tall, towering. Okay. See, in English, you find this expression on cloud 9. When someone tells you they're on cloud 9, they're essentially saying that they're on top of cumulonimbus cloud. That is the literal meaning. On cloud 9. This was the 9th cloud, according to the poem. So, cumulonimbus cloud is what you are when you are on cloud 9. When you clear civil service examination. Got the meaning? So, please understand, certain textbooks will classify cumulonimbus clouds as low clouds. It's incorrect. Cumulonimbus clouds grow over all the heights. Okay, so that was the end, showing you just the pictures so that you understand how cloud variation happens. So two things you need to notice. First, with reference to the height moving from high altitude to low altitude. And second thing, if you don't notice, the first pictures which you saw was more and more transparent. You came to the lower pictures, it was more and more opaque. The thing is, with more ice crystal concentration, think back to albedo concept again, ice crystals can reflect large amount of sunlight. So because of them, they are very, very bright and shiny. But you come to water droplets, you cannot get that shine. So the transparency will reduce and clouds become more and more opaque. You get it? So that was a segment on clouds. Let me take you to precipitation immediately. There are 4 types of precipitation. 2 are very easy. 2 requires explanation. We'll just finish that and have our break. Is it clear? Precipitation now. Precipitation. So, water in liquid or solid state reaches the Earth's surface. That's all. Reaches the Earth's surface. That's it. Water in liquid or solid state reaches the Earth's surface is called as precipitation. So when will this happen? Think back again. a water droplet gets suspended in the atmosphere because of convective currents. Convective currents. Right? At the same time, because of its weight, there is a gravity downward component. There is a gravitational component. Is it clear? See, very simple. If the number of water droplets is going to amass, then definitely there will be more and more coalescence. The size of the water droplet will begin to increase. If the water droplet or ice crystalline condition begins to grow in size, then gravity will become the dominant force. So when gravity overcomes convective currents, this will fall down and reach the Earth's surface. That's all. Can be a water droplet, can be an ice crystal. Okay. 4 forms of precipitation. 2 are very simple. 2 requires explanation. 2 are very familiar. One you experience pretty much, currently in this climate, if you are in Chennai, every day, rainfall. Hold on. I believe you've taken down. We just see the 4 forms. Forms of precipitation. 4 forms are there. 2 is easy. First is rainfall. So when do you call something called as rainfall? Simple. Liquid droplets reach the Earth's surface. That's all. This is something you know yourself. Liquid drops. So liquid drops reach Earth's surface. Rain. Second, again easy. Snowfall. When do you get snowfall? Opposite condition. Solid state, but this time, be careful, solid ice crystal. Solid ice crystal. Okay. These ones. They have a beautiful shape. That is your crystal. So crystals reach the Earth's surface. In possibly Hollywood films, you'd see these, isn't it? That is your snowfall. 2 more forms are there. One is sleet and one is hailstones. Okay, we'll see sleet right now first. Rainfall, snowfall. Number 3 is sleet. Okay. Rare form of precipitation. Why it is a rare form? Because it occurs in zones of temperature inversion. Zones of temperature inversion. Temperature inversion. Think back to temperature inversion. I've already told you, but one problem is I've taught you temperature inversion in the stratosphere and upper atmosphere when we looked at ozone formation and ion formation. Is it not? See, assume, please note, because when I teach this, people ask me the question, sir, you only told that with, again, I don't like the word you only told. Sir, you told me that with increase in altitude, there is decrease in temperature, but now you're saying to assume a condition where there is increase in temperature. See, there are certain environments on Earth for a very short span of time, temporarily, there will be increase in temperature. So assume temperature inversion condition exists. You need to take the assumption right now. Locations I will show later. So condition of temperature inversion is with increase in altitude, the temperature should increase. Right? That's what I told you. It is a rare form of precipitation. Doesn't happen very frequently. So let's take 2 different layers of air. This is my surface. Surface. From the surface, if you go 2 kilometers, okay. Let's say in this layer of atmosphere, temperature is less than 0 degrees Celsius. I'm just trying to draw a condition when could sleep be possible. That's all. Take this down. Next, let's take one more layer of atmosphere, 1 kilometer, where temperature is greater than 0 degrees Celsius. Look at the condition right now. With increase in altitude, there is increase in temperature. From less than 0, you're going to greater than 0. As time progresses, we'll picture that there is a cloud right here. And from this cloud, there is snowfall. Listen. Snowfall. Got it? You clearly know snow is your solid state. Track the snowfall. Temperature is greater than 0 degrees Celsius. Due to high temperature, This solid ice crystal will melt to water droplet. Solid state is getting changed to liquid state. Yes or no? Now come to the next layer. When the water droplet falls to the next layer, see what happens. This is interesting. Temperature is less than 0 degrees Celsius. But in this case, water droplet will get converted to ice. Liquid will get converted to solid state. There is no doubt. But the solid state will be an irregular ice pellet. It won't be the ice crystal shape which you saw, because ice crystal is possible only when gas directly becomes solid. This ice pellet, the irregular shape structure, is called as sleets. That is why sleet is also known as refrozen rainwater. Refrozen rainwater or freezing rain. Refrozen rainwater or freezing rain. Is it clear? Very, very rare. Very rare. We are assuming temperature inversion condition. I will definitely show you a location where this happens frequently. That's in regions of Europe only, not here. Here it's very, very rare. Like close to impossible because we don't have the climatic condition. Tell me whether you're done. I'll go to the last form. Then I'll give you a break. Video. Once you're done, just give me a go. I'll proceed. Okay, fine. Thank you. So now we need to look at something which you would have seen at least once in your life. You should have seen this at least once in your life, called hailstones. Number 4. See, hailstones are possible only in a cumulonimbus cloud. You need to have this vertical cloud growth. So why a cumulonimbus cloud? See, only in a cumulonimbus cloud, you'll have different layers, right? So different layers with difference in temperature. Ice crystals, the super cooled water will be there. Water droplets will be there. Okay, you might have ice pellets also. All of them will be circulating within the cloud. That is why. So let's picture a very small ice pellet right here. Fine. When the water drop is moving within the cloud, it comes in an area of low temperature. It becomes ice. Ice pellet, a very small place, ice. The small ice particle is there. Again, I insist again, it is not snow I'm talking about. Water droplet is there, gets converted to ice during movement, low temperature. This ice pellet, due to weight, it is falling down. Got it? There is a huge gust of wind, vertical movement. It will keep on feeding the cumulonimbus cloud. During this vertical movement, let's say that the ice pellet is pushed to different regions. This rolls over, comes here. During its movement, let's say it comes into an area of super cooled water. Super cooled water. So once it comes in super cooled water, the particles will begin to bind over itself. We just saw, isn't it? Nucleation process. Once it binds over, similar to how he initiated nucleation, the size will begin to increase. Right? Again, this will fall down. Again, there is one more convection. It will go rolling over. Again, super cooled water. Size begins to increase even dramatically. The size becomes so big, then it will fall down as hailstone. Got the meaning? So only in a cumulonimbus cloud where there is vertical movements, this type of mobility is possible, where air parcel can circulate an ice pellet into regions of supercooled water. Okay, that can increase the size and capacity of the ice and hailstones. All right. We'll just see a very short video. And the video will give you a better idea of how they look like. The hailstones which we get in Chennai and Tamil Nadu is not very big. Okay, we'll just see one right now. Just hold. Right there. You just tell me whether it's audible for you. I know the ad is moving on, but still.
కానీ పని ఇలా ఉంటుంది.
Is it audible?
పెయింటింగ్ లోంచి పెయింట్ తీసేసి అర్బన్ కంపెనీ ప్రొఫెషనల్ పెయింటర్స్ ని పిలవండి. రాసిస్తాను. ఇంత అద్భుతమైన వర్క్ రీజనబుల్ ప్రైజెస్ లో ఎక్కడా దొరకదు.
Severe Storms researcher Tim Samaras went into the field in the spring to document lightning and tornadoes for National Geographic. But sometimes the unexpected happens. And with cameras rolling on this day near Watonga in Kingfisher, Oklahoma, Tim and his team found themselves in the midst of a destructive hailstorm. But this wasn't the worst of it.
Very strong inflow.
A strong updraft is one of the main ingredients of a hailstorm.
God! Did you see that? Big one. There they are. I got him. That was a huge hailstone. This is the risk. I mean, that would kill somebody.
That's amazing.
I'm not so sure. There's another one falling. I don't know, man. It's probably not safe getting down here. Oh, big stuff. They're coming down the hill. Let's get out of here. My window's already broken, but I don't want the side windows to break. There's another one. Whoa. Whoa. Wow. Pretty big. Tim's got some. Wow, look at that monster. This needs to be measured. That's 4 inches. There's another one. Yeah, let's get out of here.
Keep it.
Well.
Keep the big one.
Oh, look at that one. It's huge. Look at that one. You guys are going to get killed. Look at this thing. Guys, come on. Here you go. Look at this. I know. Let it go. We're going to die.
Baseball and nearly softball-sized hailstones falling by the thousands.
That's beautiful. Look at that.
Tim measured the biggest they collected at 4 inches, nearly the size of a softball. Any hail larger than 1 inch in diameter triggers a severe storm warning by the National Weather Service, damaging to crops, people, and animals, and car windshields.
Oh, geez.
Tim Samaras and his team will head back into the field in search of tornadoes, lightning, and maybe even another big hailstorm.
See, just 2 points I want to add. First is to tell you the size of the cloud. I think this picture tells you quite an amount of how expansive the cloud is. See, these type of clouds are called as supercells, and they form in regions of extratropical cyclones. When we see cyclones, we'll come back to that. Just remind me, and I think this kind of puts a clear picture, you know, how big the cloud is again. Yeah, this one. You can clearly see the impact of surface. You just compare it with how much surface area is on the ground and just look proportionally there. You'll be able to understand how big a cloud is. And to appreciate that vertical upward movement, just look at the wind velocity which you see in this short few seconds. Just picture the wind velocity which is at the back, you know.
Very strong inflow.
So only that updraft
A
can
strong
keep
updraft
a
is one
cloud
of
of
the
such
main-
enormous size on top. And that updraft is the reason why that circulation happens and that can hold large number of heavy particles. Once the updraft weakens, then all of them begin to fall down. Now the size should become bigger. Okay, so that's with the fourth form of precipitation called as hailstones, possible only in cumulonimbus clouds. Now, finish with the last statement. Why don't we get the same size in India or in Tamil Nadu when compared to the size which we find in the United States? See, please understand the answer lies in latitude. This could be, I think this is Oklahoma, you said Nebraska, so it's quite far away. You're talking about latitudes of 35 degrees, 40 degrees north. Chennai is in 12 degree north, 13 degrees if you want me to be specific. So if a hailstone of that size is going, it may start from the cumulonimbus cloud, but by the time it reaches of Chennai's temperature, you know what will happen to this? Okay, it might become few water droplets, maybe even water will evaporate before hitting the surface. So that's with reference to clouds. Now I'm going to continue with human geography. Take a break for 5 minutes. Meet you after that. So we'll continue from human geography. So can you explain adiabatic process and convection process? Raj, I'll take the doubt at the last. Okay, we'll do it, but we'll do it at the last because I want to specifically know where the miscommunication is there. So we'll do that. Since we are stepping into another topic and we still have global atmospheric circulation, a larger portion, equatorial climate will need to be complete. We'll take all those sessions and then I'll come back to doubts. No problem. We'll take it up, possibly 775 before we close the session. So this is lesson plan for human geography. I think we'll need to overshoot 430. We'll try our level best. See, again, let me tell you the material which you'll need to read. See, the topics which I handled so far, right? The climate topics. Properties of water won't be there in NCERT, but others will be there in Fundamentals of Physical Geography, 11th standard NCERT. This is your 12th standard NCERT, Fundamentals of Human Geography. And in that, I want you to focus on the second unit alone. Second unit is about your world population. Basically, world population characteristics. The other unit I'll handle indirectly. Let me tell you why we are actually placing human geography instead of just, instead of just continuing with climatology. The thing is, when we start with climatic regions, which we could do it today if time permits or tomorrow for sure. So under climatic regions, we need to look at industrial location. Not just industrial location, we just need to look at what is the economic activity, what is the level of human development, and do we have any social or economic problems in that region, specific to the region. So if I need to teach you this, then you need to understand certain fundamentals in human geography. Without population, without industries, it will become difficult when you go to your climatic regions. So it's like this always, human geography will be handled together. Map reading also insisted the same thing. I've already given you resources. So human geography is encased inside physical geography. So I give you the introduction, then every part of physical geography you deal, you'll be able to immediately make the connection. That's why we are taking, placing this. This is not misplaced, but that is the way to handle. You're still moving linearly. Okay. Before climatic regions, we need to take it up. So let me repeat the lesson plan for you. So characteristics of population, world population growth, density and distribution, demographic transition theory, a theory of population growth, very comprehensive. Related to DTT, we have three related concepts. We have age, sex pyramid, sex ratio, total fertility rate, and life expectancy. Then finally, just a small, short introduction on industries and settlements. That's all. Just possibly 5 or 10 minutes. It's the population section we'll need to spend enough time. So let me recollect growth of world population for you. And this is something which we do with the evolution of Homo sapiens. Think back. These notes you would have had it in map reading. I would have told you we migrated from East Africa and we extended to the entire segment. And later we moved from Siberia to the Americas. So from the Americas north to South America. And from Southeast Asia by constructing boats, we reached Australia. Aboriginals, and these were your Native Americans, right? See, please understand, even though human beings were able to spread over a larger area, even we did start agriculture, human population also always faced a resource dilemma. What resource dilemma are we talking about? Well, X is my time axis, and Y is my population or my productivity or production, efficiency, anything you can take. See, there is always a vertical limit for any region to produce beyond that. Let me take India as an example. You can take the first largest empire in India, Ashoka's empire. High level of production, productivity, population will be there. Then when Ashoka has passed away, then the subsequent time periods, collapse of Ashoka, post-Mauryan, Guptan, post-Guptan, medieval, okay, where you'll find, then you'll find Harsha, after that Harsha medieval time period, after which you find a Delhi Sultanate. Then you'll find your decline of Delhi Sultanate, then your Mughals, finally starting from Ashoka ending in Aurangzeb. After Aurangzeb, you'll have your decline. See, thing is, everyone would not be able to finish or grow beyond a certain vertical limit of production, population, or efficiency. Why exactly is that? Well, the answer lies in resource limitation. See, understand, you take any region, the region can essentially support a population of, let's say, 100 people. Let's take 100. Is it clear? At the start, maybe there were only 50 individuals. Over a period of time, with better efficiency in usage of resources, the population begins to increase. So 50 becomes 70, 70 becomes 90, 90 becomes 120. See, based on the existing technology, you can produce enough resources and enough potential can be given only for 100 people. Once the number exceeds to 120, then it becomes a problem. That is when you get war, disease, conflicts, poverty. There is struggle and there is population decline. Again, it comes back to 60. Growth, 120, comes back to 40. The same process repeats over and over and over again. And this idea was properly theorized by a pastor who gave possibly the first world population theory, Robert Malthus. Robert Malthus. Okay, and Robert Malthus insisted that food production will not be able to keep pace with population growth. Food production will not be able to keep pace with population growth. Population will always grow faster compared to food production, and this will lead to conflict, disease, and poverty. And again, there will be decline in society, decline in population. I believe you got the idea. Video is not visible. Oh, wait. Hold on. Thank you for telling me. I don't know when you got cut, but no, wait, hold on. Let's see where we can rectify. Possibly net. Sorry for like, it's something out of control, right? The only problem, not the only problem, there are several things which I hate about online classes, and this is one. The most important thing being not able to see your face, because without the student's face, faculty doesn't get instant feedback whether what they are teaching is receiving the students or not. Apart from this, the hand of God, if you want me to quote the government of India, so not us, the hand of God. Why GST compensation is not provided? Hand of God. Okay. Yeah. I'll. No, act of God. Sorry, hand of God is. I just, I just mentioned the word from Diego Maradona's goal, 1986 match versus England. Hand of God. Okay. Yeah. I'll repeat. No problem. I'll repeat. Yes. I'll just tell you the lesson plan also. No worries. Hand of God. The since he scored the goal, there was a change in the game. If Maradona hadn't scored the goal, we don't know what the result would have been. Because once you score a goal, then the second goal becomes much easier. There's change in psychology, entire game changes. Maradona called it hand of God. The English coach called it the hand of rascal. So it depends upon the side where you are in. So either act of God or act of, anything. Is it clear? So it depends upon the perception. We view something. Everyone is entitled to their opinion. So coming to the lesson plan, I was insisting that you work on fundamentals of human geography, the first unit. First unit is essentially about the population characteristics. So world population, growth, density, and distribution of population. Demographic transition theory, again associated with how population changes in an area. Then age sex pyramids, total fertility rate, life expectancy related topics, basics of sex ratio. Okay, again, world perspective. Then finally, industries and settlement pattern. Okay, just 5 to 10 minutes on this. This is where I believe it got stuck. So we'll start from growth of population. This is just a recollection of what we saw with reference to your map reading class. Before we started with the United States of America and 13 colonies, we insisted that human population evolved in East Africa, and from East Africa they migrated to Eurasia and Europe, and one segment migrated towards your Americas, reaching South America, and a smaller segment from Southeast Asia moves towards Australia and the other Polynesian islands, the Pacific. Okay. Now, one interesting fact regarding this entire migration is, in spite of the fact that humans were able to colonize a large region, they faced with an enormous challenge. And that challenge was put forth by a theory by Robert Malthus. So I was drawing a diagram on what you can experience in terms of population growth or economic growth for any empire for that matter. So if x-axis is your timeline and y-axis denotes your population or your economic growth, So the point is, any empire you take over India itself, we'll take India as a region, they will experience growth, and after that there is decline. Ashokan Empire, decline. Guptan Empire, decline. Harsha, decline. Early medieval time, decline. Delhi Sultanate, decline. Mughals, decline. So be it Ashoka or be it Aurangzeb, only up to a certain level they can reach or increase population or economic growth, and after that it's not possible for them to breach this level. This is named after the person who gave the theory. His name is Robert Malthus. So from his name they derive this terminology, Malthusian trap. Malthus gave a very simple theory. He said, see, every region has a basic limited amount of resources which can support a population. If you are assuming a region which can support 100 people, then ideally, if you overshoot the population is 60, it is natural that population will increase. But if it increases beyond 100, let's say it goes to 120, 130, then this region will not have the capacity to sustain the population. So this 120 will start fighting among themselves. There will be poverty, there is conflict, there is war, and because of that, population decline backs to 50 again. Again, there is growth to 100 or 110. Again, the same process repeats over and over again in the cycle. He says any region will not be able to break the Malthusian trap. You get the meaning of the word trap right here. Because food production will not be able to keep pace with population growth and demands. Population growth and demand will always be much greater than your food production. Is it okay? So just some information on when he gave this theory. This is around 1798. That is when Malthus gives his theory, and from the perspective of 1798 world, if you look at it, it is true. World population and our economic growth, like as any region of the world you take, has always remained stagnant at one particular level. It will be a straight line. Since we started agriculture, maybe agriculture, there is a slight increase in population. Apart from that, you take all parts of the world, there will be a straight line. Population graph will be like this, moving very, very linearly. But there is a change, and that change is brought about around 1800, 1780, 1800, 1820. After 1820 only, it begins to go rapidly. That is Industrial Revolution. Industrial Revolution, again, we revisit from map reading, just recollecting. Think back again, Industrial Revolution. Like again, relate to your map reading notes. For the first time, machines are used in a large scale process in your industrial production process. So one beauty about this is now machines can produce for everyone. Their efficiency is 10 times. So even though the resource is limited, now we are actually changing the meaning of what exactly can you term as a resource. There are more and more colonies. Resources can be taken from all the colonies, and there are more and more advantages because of using more and more machines. So this breaches the Malthusian trap. If Robert Malthus was living in 1880, possibly 60 years after Industrial Revolution properly takes off, I don't think he would have given this theory. But understand, unlucky for him, he was before Industrial Revolution, and only after Industrial Revolution, both population and economic growth sees a very dramatic increase. Okay, and I think the graph at least is fairly visible, the blue color line. Okay, so you're just looking at how frequently the population is going to doubling time. So 1804, the population is 1 billion, 1927, 2 billion, close to 123 years. For moving to 2 billion to 3 billion, it takes 33 years, 1927 to 1960. Within 14 years time period, contribution of our parents, 1960 to 1974. Now, contribution of our grandparents, they contributed, 1960 to 1974, 3 to 4 billion. Okay, 74 to 87, 5 billion. Okay, now I think most of you will fit the graph. 87 to 1999, 6 billion. Okay, this is our parents' contribution. We are part of this generation. And then 2012, we come to 7 billion. 2024, we are expected to reach 8 billion. You know, right now, we are at 7.7 billion or 7.8 billion. We'll definitely reach 8 billion. We will do it 2024. And we are expecting to flatten around 9 billion around 2048, but some projections say it can go to 10 billion. Is it clear? Only because of Industrial Revolution, population growth has shot up like anything. That's something we need to appreciate. And this has created a huge science of demographics and several population characteristics. So what we need to understand is, we do appreciate that population has grown, but how does population grow in an area? How does it happen? Is there a pattern? Is there a trend? That is what we're going to understand. Is it clear? And that is provided by demographic transition theory. Demographic transition theory actually analyzes how population changes in a region. Population growth, change in a region. Is it clear? The region can be anything. It can be a city, state, country, anything. So several theories have come regarding population. This theory has been successful and applied even today because this connects population growth strongly with economic development, tries to trace population growth with reference to when any society moves from a rural agrarian economy to an urban industrial economy. So when you move from a rural or primary sector scale to an urban industrial scale, how exactly does my population change? That is propounded by demographic transition theory. They gave this theory, Edward and Ottiston, after collecting data from several countries. You know, that is how they actually formed this. Okay, so quite successful in explaining all the processes except for some pitfalls. Pitfalls we'll see later. Okay, so rural agrarian to urban industrial society. So what are the changes? I'll proceed. See, this is the name, Warren Thompson and Frank Ottiston, who gave demographic transition theory. Hold on. See, again, slide will be given to you. There is no problem. I can send the slides. I'll ask the academy coordinator to pass it on to you. What is more important are the discussions which are handled in class apart from what is written in the slide. Is it clear? Because for Malthusian trap, there was nothing right here, but we did discuss quite a lot. So what is discussed in class, you rather take more, need not copy what is exactly there in the slide. Let me explain the process, then finally we can draw this graph. Is it clear? Shall I start? Let me explain the graph first. Are you ready? Then I'll give you time, then you can draw, no problem. Okay, fine. So I'm going to start from what parameters do they take? See, Edward and Frank are focusing on two basic parameters to dictate my population. They are going to talk about my birth rate and my death rate. Let me recollect the crude definition for you. Crude birth rate is number of children born. And death rate is again number of individuals per 1,000 population who pass away, number of births per 1,000 population, like for 1,000. So that's my birth rate and that's my death rate. See, think back. You're talking about the transition from a rural agrarian society to a urban industrial society. Recollect again. They say at the starting stage, when the society is rural and agrarian, possibly involved in the primary sector, then the birth rate opportunity and death rate, like both of the values will be extremely higher. So that is what is there in the x-axis. Sorry, that is what is there in the y-axis. Births or deaths per 1,000 population, and y-axis talks about time. It's moving from rural to industrial. See, please note, we need to appreciate why birth rate is high, why death rate is high. Why is this the first case? High birth rate and high death rate. This is stage 1, which you find right here. The blue color line represents your death rate and the pink color line represents your birth rate. The point is, in an agrarian or a fishing or a primary sector society, if 100 individuals are there and 95 to 96% of them are involved in primary sector activities, the per capita income will be very low. It's only in the services sector that the per capita income increases. So the income and revenue of most of the population will be low. Is it clear? Graph you can copy. This discussion you can take. Is it clear? Graph will give you time. So high birth rate, high death rate, most of the population is involved in primary sector activities. Their per capita income is low, which means there is more incidence of poverty. It's a very simple link. If there is more poverty, you have learned it in cycle of poverty. More poverty leads to more and more children, more and more birth rate. Well, why is the birth rate high? Why do the parents want 6 individuals, 8 individuals, 10 children? It's simple. Let's say I'm a poor man. I'd like to have 10 children because if I have more children, then I have more laborers. Okay, I can ask each one of them to go and work, and when they work, they'll give me more money. And in my old age, if each and every one of my children give me just 1 rupee, I'll be earning 10 rupees. So it's just economics, that's all. So with increase in incidence in poverty, there is a natural tendency for the birth rate to be on the upper side. So more births, easily explained. Okay, fine. Why is my death rate more? Think back again. The society does not have high amount of investment in both education and healthcare. Large section of population do not know the importance of sanitation. There is not much awareness on communicable diseases, and people do not have the money to really spend on medical care also. And the government is also not very powerful in aiding because it's concerned about its defense, possible areas where it needs to concentrate. So that is why my death rate is higher. Lack of awareness, poor education, poor healthcare, not much importance given to sanitation, either by people or by the government side. So that's why high death rate. So people die at a very early age. Okay, there is more number of children dying. At the same time, rarely people cross 65 years of age. You wouldn't find them in the society. Let time progress. Okay. See, as time progresses, let's say that there are few individuals out of this 100% who decide that from the tomatoes which they cultivate, they want to add some sort of value and make possibly tomato sauce, or maybe they want to manufacture ketchup. Again, note carefully, it's not that the entire population is moving, but a very small section, let's say 20 individuals, 25 individuals try to move towards manufacturing. Okay, so from there, a primary sector, slow transition. So once you come to stage number 2, this is a stage where the birth rate is higher. Okay, but you talk about your death rate is going to decline. Death rate declines. Now, why does this second stage happen? Think again. You move towards the secondary sector. Again, not a large, but a small population goes towards the secondary sector. The per capita income will naturally increase. Once your income increases, any parent invests on 2 things only. First of all, they talk about the education. Even before education comes health of the child. So now what is happening is birth rate is not increasing. Please note, birth rate is still consistently remaining high. It's still there. It's still the same. But on the other hand, you look at your death rate, since constructive measures are being taken in both healthcare and education, death rate will begin to drop down. This is more of a drastic drop in death rate. Is it clear? But they're still having more children because larger section is under poverty yet. Is it clear? Now, there is a gap between birth rate and death rate, isn't it? There is more birth rate and there is less number of deaths. You are reducing your deaths. Naturally, population will rapidly increase. This is the stage of your population explosion, stage number 2, where there is immense amount of population growth. Meaning makes sense. Now, time progresses. See, this is the time period when not just a smaller section of population, but a good number out of 100, let's say 40% of population are moving firmly towards a secondary sector economy. And now people are moving towards services, possibly banking industry, tourism industry, trade industry. They are moving towards your services sector, more and more operation. Is it clear? Tertiary sector. Now, you clearly know tertiary sector has the highest per capita income and manufacturing is already establishing its base. Now, with increase in per capita income, two things happen simultaneously. First, let's talk about your death rate. Death rate was already declining steeply in stage 2. You come to stage 3, death rate is very low. You can use the word low. It's not declining anymore. Death rate is almost reached its low level in stage 3. Now, you look, one important thing, birth rate is not consistently high, but birth rate is declining. Birth rate is declining. Why does it happen? Because any region, any government will definitely try to take measures once population begins to explode. Now, government is trying to encourage people to use contraceptives. They're talking about the problems of having more and more children, that it can lead to a cycle of poverty. So please cut down your birth rate. Government advises active measures are being taken where you want to constructively reduce birth rate. So once there is government measures, yes, there is reduction. Please note, there is still a gap between birth rate and death rate. The gap always persists. But the thing is, the gap is getting narrowed right now. The gap was very, very big in stage 2. But right now, the gap is getting reduced. So that's why we use the word death rate is low. It's almost flattened down. But birth rate is still declining. People are becoming more aware. Government schemes are getting initiated. And finally, in the last stage, stage 4, we've already reached a stage of low death rate. But this time, birth rate becomes very low, close to death rate itself. This is a type of economy where most of them are in services sector and manufacturing sector, and in primary or agrarian sector, the percentage is very low. Now, can anyone tell me, why did my birth rate become very, very close to death rate? What initiated this process? Okay. Like, of course, decline was okay, government schemes, policies and others. But why did the birth rate kind of become very low, close to death rate? You should hit the nail, just like that. Two responses were not exactly hitting the nail. See, there should at least be one parent. The parent should work-life balance. Simple or விஷயம் இருக்கு. Not able to take care. This relevant answer. Super. Very good. CIN 2079783. That's hitting the nail. Cost of living, people. You know how difficult it is to finance a child, especially in an industrial society? Their appetite is very high, especially in this stupid COVID environment. Do you know how much you need to spend just for keeping your environment clean? See, 20 years ago, 30 years ago, our parents do not even care about anything. Now, everything has to be clean. Nonsense. Sanitizer was a word which did not even exist in the dictionary 20 years back. Now, everyone knows what a sanitizer is. Think about education cost. See, honestly, I believe that the amount of fees which you paid for studying UPSC, Civil Services Examination, is actually equivalent to the fees which you pay for kindergarten along with donation in any school. 4-year-old, 5-year-old kid, you need to spend as much you spend in UPSC for just getting it. What A, B, C, D they will teach you? Adikolo fees. Okay. 10 children, the poor man is not financing them for anything. But you take this one, these are monsters. They might be small, but they have a huge appetite and you need to keep feeding them more and more. And people themselves decide. Government is not deciding, but people come to a conclusion. Rather than having 10 monsters, we just have one and feed it because we can't really work. Once your cost of living increases, the expenses is so hard. Apart from the other factors, I do get it. Like both the parents are working, you don't really have time to take care of the children. But apart from that, this is economically unviable, cost prohibitive to have children. So the society itself, the individuals themselves decide they don't want it anymore. Is it clear? So please note, in stage 2, there was population explosion. In stage 3, there is still population growth because the space is there. As long as there is space, population will continue to grow. And in your final stage, the population begins to stabilize. So they say any region, there will be population stabilization at the start with high birth rate and high death rate. You come to the final stage, population again re-stabilizes. But this time with a low birth rate and low death rate when you move from an agrarian rural society to an industrial urban society. Is it clear? Here government is not needed. Individuals still will decide. Okay. I still like this dialogue from this film, Age of Ultron. Ultron is very philosophical, isn't it? And Ultron says that people always create things which they dread, which they fear. So people create small people, which are children. Is it clear? Shall we proceed further? Any doubts? I mean, I need to give you examples. Just tell me whether I can move ahead. These are 4 stages. I think now the diagram makes much more sense. Okay. One more response, I'll proceed further. Yeah, fine. See, if you actually think about it, you can place any country in different stage of demographic development. For example, United States of America is actually in stage 4. You get like highly industrial society. You take a country like India, India is actually in stage 3. Now, don't mistake me, it's not in stage 2. India's birth rate is declining. We are moved from stage 2. It's like not in the right hand side of stage 3, but in the left hand side of stage 3. India is just there. We are punching through. Very good. Slowly we'll move there. China is actually here. They've crossed over. They're crossing over from stage 3 to stage 4. Basically, so different countries, you can try to fix it in the chart. Now, point is, within India, different states will be in different stages. For example, you take Bihar or Jharkhand, they might be in stage 2. Is it clear? You take Kerala, Kerala will be in stage 4. Okay, you take either Maharashtra or Tamil Nadu. Maharashtra, Tamil Nadu will be, are actually in stage 3, moving towards stage 4. Okay, they are on the right hand side. Is it clear? Within Tamil Nadu, you can have different districts. For example, Chennai is already in stage 4. Is it clear? But you take a city like Coimbatore or Madurai, they'll be in stage 3. Madurai or Coimbatore. Meaning makes sense. So any region, you can break it down. It can be a country, it can be a state, or even a city in a state. So that's the brilliance of this theory. Okay, very good, very applicable, and easily understandable also. Is it really possible to stabilize the population? Yes, population has stabilized in several countries. In fact, population is declining in several countries. Will demographic dividend affect because of this? How to balance that? Repeat the question. Will demographic dividend affect because of this? Okay, I believe you're asking, will demographic dividend get affected if you move here? Because after that, young population won't be there. Yes, that is a problem. How to balance that? See, please understand. We will discuss with reference to China. I'll take China as a case study when we come to population factors. Please note that there is one criticism against the theory. I'll give the point now itself. In certain countries, the population is actually declining. That is one problem with this theory. For example, Japan, Russia, Germany. So these are having negative population growth. Okay, very, very low. Okay, you have total fertility rate of 1.6, 1.7, not enough. So in these places, you don't have enough human beings, which means your consumption will reduce. Your consumption will reduce, your working age population goes down, then your economic pie won't expand. You can't produce as much as more, which means one individual should consume as much the others are consuming. And coming to the second question which was posed, so what is the challenge for any country? Please understand, it is inevitable that every country will move from stage 1 to stage 4. During this process, population will naturally stabilize as you move towards the secondary and tertiary sector. Point is, listen, before you come to stage 4, or at least when you are in stage 4, you will need to shift a large section of population out of poverty. India is actually not doing that. if you don't push population out of poverty, India will reach stage 4. Population will stabilize, but most of the population will still be reeling under general problems of poverty. You take the report in newspaper today, malnourishment. India has the largest population of vaster children even compared to Pakistan and Bangladesh. You saw the hunger in the malnourishment data, isn't it? So that is the challenge with India. When your demographic dividend is there, 30 years and 25 years only, you'll have the window. You use that window properly and push the country out of that poverty trap. You don't push it, you'll be an old man who's living in poverty. And there is no respect in international stage. Countries are ready to negotiate with India only because of India's demographic dividend. 30 years from now, no one respects a person who's old and is not earned enough in his young age. That's the problem. Is it clear? Why not India follow or implements China's one-child policy? CIN 2034875. One-child policy should never be implemented in any country. Please understand. China is facing incredible amount of problems. We'll talk about China, but please never ever support one-child policy. Because it was a virulent policy. If the government knows that the woman is actually pregnant even with the second child, they'll go for forced abortion. And if the forced abortion kills the woman, Chinese government doesn't care. If you have a second child, let's say you did use protection and still it led to a child, abortion is not possible. The government will make you pay a fine, and you'll not be able to pay the fine till your death. You'll need to work 25 to 30 years only for that. You understand the meaning? One-child policy happens in a dictatorship. Is it clear? Where you happen in an iron government. You can't do that. You cannot force people that you should have it, which means that's a fascist government. That's all. And because of one-child policy, China is facing problems. So never ever support that policy. See, people have died because of that. That's not something to be appreciated. Why can't India follow? India shouldn't. India is already reaching the level. Okay, so no problem. Don't worry, like Indians will reduce. So please never ever support the policy on any ground. Be it your mains answer interview, don't support it, because it's a fascistic principle that you can control sex. Like when a government at any point of time tries to control sex, that is an indication that you're moving towards fascism. Anything. You can use any mechanism. You can say it's due to culture, due to civilization, due to society. Nothing. You're trying to control sex. It simply means you're trying to control your population. You want your population to do something, okay, which means the authoritarianism is increasing. So sex is a very good indicator. The openness to sex will indicate, how authoritarian a particular government is. Okay, so this is evaluation. I have told this to you already. Statistical and based on scientific evidence. They collected a large amount of data before they propounded this theory. First theory to link it with economic development, and has wide applicability, as seen in several countries and states. Now I want to talk about world population characteristics. We'll go one by one. Let me just show you the rundown first. See, first we look at population, then population density. After population density, 3 factors. Pyramid, life expectancy, and total fertility rate. All of them are connected. Only the first part I need to provide something. See, first we are going to look at the top 10 countries in the world in terms of population. We're going to compare. See, I just read certain values, that's all. The exact numbers are not required. We're just going to compare with the next slide, that's it. So China, India, USA, Indonesia, Pakistan, Brazil, Nigeria, Bangladesh, Russia, Mexico. So you read it, it's fairly widespread. You have countries from America, countries from Africa, countries from Asia, no doubt. So Asia is quite dominant right here, including Bangladesh. What we need to understand is, if this is the arrangement based on population, what about population density? See, please note, density is just a mathematical component. You're talking about number of people, the size of population per unit area, per square kilometer. So it's not about your population of your country. What is more important is, how is my population density? Are more people present in an area, less people present in an area? Population density provides you an idea of how far your resource availability is. If it's more denser, more people live per square kilometer, which means you have serious problems. Now, same 10 countries, we're going to look at it in the prism of population density rather than population. Ready? Number of people living per square kilometer. See, all you need to look is the number of digits, that's all. I'll just take the first 2 countries of interest. Russia 9. Bangladesh 1265. Can you imagine the number of people in terms of population density in Bangladesh? Very fertile plain, Ganga Brahmaputra region, an extreme population. You cannot even compare with Russia. Why is Russia's population density so less? Because Russia is the largest country in the world. To give you the analysis, Canada is the second largest country in the world, and Russia's size is almost 2 times bigger than Canada. It's so big. Population density is natural to be less. Now, you think that India's population is less than China. So 1.4 billion, 1.3 billion. India doesn't have a problem. Look at it in terms of population density, India is in serious trouble. China is 3 times larger than India. So 153 is the density. Look at India, 464. 3 times more problems. That's all, much denser, which means our efficiency should be much, 3 times better than China to actually facilitate proper economic development. Let's take USA. USA is only 36. Why again size? You have Alaska, you have the great plains in the northern prairie region, the western and the eastern coast, a very extensive land area. So India is like 10 times, not 10 times, 13 times denser than the United States of America. Like one more country which is very less is Brazil. Brazil, you see that population density is again less because large area comes under your Amazon forest region. So what we'll try to do right now is to make sense of what essentially governs my population characteristics. Why do certain regions have more population density and more population and the others doesn't have? So for that, we are going to move to factors. Factors affecting population growth. Is it clear? It's better to control population than allowing 4 babies per family to live under extreme poverty in India. I think it's again, I will be spending some time on this question because if you're insistent, please understand, you need to understand this because, please note, utopia is an ideal society and there are several theories that if you do certain amount of things, ideal society meaning you want a picture of utopia, there is a land, everyone is happy, everyone gets food, everyone gets to do a certain, whatever they want they can do, something like that. That is an utopia, not whatever they want. You're talking about a society where certain restrictions are present, but everyone gets food, everyone gets housing, everyone gets to do things which are allowed by the government in utopia. People who live in an utopia need not necessarily be happy. You get it? And every single time you try to move towards an utopia, you create a dystopia. Dystopia is a very bad condition, a very non-ideal condition which you don't want to achieve. See, when people want to, so why do we want to have only 2 children? You say we only want to have 1 children or 2 children and enforced by the government because government feels we have so much of poverty, so much of malnourishment. Hence, we are forcing population to have this. See, this is authoritarian control. See, this is too much of power to any government. Okay, you are punishing people for something very, very natural, their ability to have children. So you need to look at it this way. If a government can control, listen, it's a very serious question. It's not something which I can pass through. You need to understand certain ethical concerns here. If a government can control, it can decide when you can have sexual intercourse, how you should have sexual intercourse, or how many children you're supposed to have, then the government can control what you can see, meaning the newspapers, what is getting published in the media. Government can control what specific type of profession is allowed. Government can control only certain level of property. You get it? This is the most extreme case. If government controls sex, government will be controlling each and every part of your life. It's not an utopia, it is a dystopia. Any person tries to move rapidly towards dystopia, it will only take them to a dystopian non-ideal condition where people are not happy. Okay, you can read dystopian classics, you can read 1984, you can read Ender's Game, you read The Giver, you read The Island, any dystopian classic you read. Every single time one commonality is government and authorities and dictators will try to control population. You can control population if they're controlling sex. It's not even population. You're controlling sex. You control sex, it means every aspect of life will be controlled. And that is an extreme case. That is why I'd always like to live in India as a happy poor man rather than live as a unhappy rich man in China. I don't want there. See, in China, there is no concept of dissent. You don't like something, be it an elected government, you should have the right to dissent. In China, there is no question of dissent. See, be it Tibet or be it Xinjiang province, if you even worship the, the religion of your choice, or even if you try to say, okay, this region needs some sort of autonomous provinces, or you want some sort of independence, you will be sent to a camp for the rest of your life. Is it clear? There is no concept of dissent in China. It is not just about economic growth. It's not just about economic growth. What is economic growth going to give you if people are not happy, if your method is unsustainable? We don't know how far China can go if it keeps on damaging its rivers and forest areas. If government can control sex, government can do anything. That's the point I'm stressing. That's an extreme step. It is not as simple as controlling. Government will tell you what to eat then. This is a foodstuff which is allowed by government of India. You can eat only this. This is a foodstuff you're not allowed. Why? Because we are following one-child policy of India. Sex is a very, very important control factor. That's the last one which every government tries to push over. They capture that, you can be very sure you're in dystopia. It's a very serious issue. It's not something which you can simply pass through. It's totally fine if I took 5 to 10 minutes on that. You should know the seriousness of that topic. Okay. Is it clear? So it's something that's very, very crucial. It's not a joke. If you can't solve the problem, you start to increase, or you start to move towards economic development, promote your secondary sector, promote your tertiary sector, automatically people will start having less and less children. They themselves will understand children are the most stupid thing in the world. There is no point of having those small things. Useless. Is it clear? So people will be made to realize, you just make them read more books, they'll understand they're useless. That's all. It's that simple. Why enforce it? Why enforce it if you can make them understand? Is it clear? Now coming to the next one, like geographical factors, factors which influence population growth and population density. Talking about water. See, water has always been the cradle of civilization. You take any civilization in the world, access to freshwater resources, be it rivers or lakes, will determine population. Largest population densities in the world or largest population concentrations are found along rivers. You can quote any example of the choice. You take Bangladesh, for example, high population density because of Ganga and Brahmaputra rivers. Is it clear? You take India. Okay, highest populations is found along Ganga river. Is it clear? You take China. Highest populations will be found along Yangtze. See, all the rivers from map reading, Yangtze. Okay, Yellow River, very high density of population. Is it clear? So access to water is very essential. Fine. Number 3, we are talking about landforms. Landforms can mean 2 things. First is my coastal location and second is my elevation. See, any part of the world, if you compare populations living between plains and mountains, plains compared to a mountainous terrain, population will be fairly high in plain region. Why is that? Because of 3 simple reasons. See, plains, it is much easier for agriculture. Correct? Or rather, you're cultivating crops in the mountainous terrain, then the entire region will have to be modified. Geoengineering techniques, you need to cut down the slope, properly change it. It's very costly and not ineffective, but it's very, very difficult. Plain region, it's much easier for agriculture. Food production, that's all. Number 2, soil fertility. See, when the land is inclined at an angle, there will be more riverine erosion, where when there is rainfall, water can take out your soil. The soil may not be very fertile, but on the plain, where water can settle down, there is more possibility of fertile soil. You take the northern plains of India, both Ganga, or you take the delta region, delta is plain. You take Kaveri Delta, Krishna Godavari Delta, very high concentration of population because enables you in cultivation of food. Number 2, plains. And number 3 is your civil engineering, settlement. See, be it house construction, bridge construction, infrastructure construction, plains are always preferred compared to mountains. That is why population in plains are more than mountains in any part of the world, mountains and plateaus. So that's one subsection of landforms dictating population. Second one is regarding coastal location and interior location. So if you're going to have a country, is it clear? And you have population comparison between the interior region and you compare with the coastal location, coastal populations will always be more. Always. The reason being two things. First of all, coastal areas give you access to two industries. What industries? Well, one industry which we don't really relate to, but a large contributor, primary sector industry, fishing industry is there. And second one, trade industry is there, tertiary sector. You're there on the coast, you can access both these industries. So that is the reason large population works here. The more population, coastal area. Second one, coastal climatic conditions always have the moderating influence of the sea. Let me write it here. Moderating influence of the sea. Is it clear? So interior climates are very, very harsh, very harsh. You take Delhi, the difference between your summer temperature and winter temperature is very, very high. 40 degrees Celsius, summer 42. You come to your winter season -2. Very difficult, isn't it? 44 degree, 45 degrees Celsius range of temperature. Okay. All these are part of demographic transition theory. No, Raj, I'm teaching you population characteristics. You didn't see the section header. Look at here. One minute. Demographic transition theory ended with this slide itself. I'm discussing population characteristics. Adila, world population, I compared density. After comparing density, we're looking at factors which are influencing population. DTT was over long back. Okay. The population character I told, no, comparing different countries, then only I went to this, no? Is it clear? So coastal location, fish and trade. And second one, moderating influence of sea. Interior lands are very, very harsh climatic conditions. That is why people prefer coastal locations, at the same time plain locations compared to mountains. Okay. Shall we move to the next point of climate? Okay, Raj. Okay, fine, Raj. Shall we go to climate right now? We'll finish this, then I'll give you a 4:30 break. We can wrap it up. Okay. Just let me know. Okay, fine. See, coming to climate, there are 3 climatic conditions which we are finding it difficult to increase population. I think 3 climates you already know. First is, we will see them when we go back to your climatic regions. First is your desert. I think the answer is fairly simple. Desert regions lack water. So because of that, population and population density has been fairly low. Second climatic condition, Arctic, ice climate. Okay, a polar climate. Here temperature is very, very low. Most of the areas are covered by ice sheets and glaciers. So grass can't really grow here. It's very, very difficult for any economic activity. Again, population is not much. You take Russia, for example, large portion of Russia, the northern segment, will be under Siberian and polar climate, very harsh. Number 3, one more area, equatorial climate. Why? Think back to Brazil right now. Brazil is a perfect example. Okay, Amazon forest, high temperature, high rainfall, high amount of plants, high biodiversity. This is an area where your natural ecosystem is much dominant. Living here is quite difficult. Is it clear? So these climatic conditions, human population is not more. You can take examples from map reading like Congo, Central African Republic, Brazil, the population is quite low. Okay, and coming to soils, I think this makes easier sense. Areas where there is fertile soil, that's all. Alluvium or black soil, you take them. Alluvial soil, black soil, very fertile for cultivating crops. So high population. Okay, these are my geographical or physical factors, physical geography factors. Is it clear? Physical geography factors. Now, talking about economic factors. Okay. Population is also governed by mineral distribution. Example, we'll take desert climatic conditions, Saudi Arabia. But within Saudi Arabia, United Arab Emirates, where climate is harsh, you still have a city like Abu Dhabi. Why? Oil is there. Because of oil, people are settling in United Arab Emirates. There is high, now there is increase in population. So oil can dictate terms because this is quite rich. You take Saudi Arabia, UAE, okay, Riyadh, and your Abu Dhabi, Dubai. You take Russia, you take Kazakhstan, you take Australia, metallic minerals, non-metallic minerals. So several cities in eastern part of Russia, several cities in Australia initially started as mining towns. There were minerals there, gold was present, uranium was present, metals were present. They went there for accessing them. Only because of that, settlements and population increase. Makes sense? And next one, I think this is fairly simple. Urbanization and industrialization. Okay, once the city environment becomes a sprawling metropolis, then automatically it will lead to more and more migration, people coming in. Okay, you take Chennai for example. Chennai's natural population would have stabilized. Mumbai's natural population, Delhi's natural population, who are natives of Chennai, Delhiites, Chennaites, you get it? But due to migration, the population will keep on increasing. The population density will be very, very high because people come here due to economic opportunities, primarily for employment and secondly for education. Is it clear? Now, not just your economic factors, but your socio-cultural factors can also influence. You want to understand religion. One example I give you, go to your parents. Religion and culture, not just religion. Any religion, any culture in India, any culture, any religion, can be Hinduism, can be Islam, can be Christianity. Go to your parents, marriage, no marriage, that you. Tell them you don't want children. You tell them seriously you don't want children, or 5 minutes they'll give one lecture. Ears will start bleeding. See, people need to have children because they want to show to others. Show to others, not show that they want to promote the next generation. Is it clear? That is the only purpose, showing off. They want grandchild. That's all. That's the only reason they're having children. Not because you want. Society wants children. That's the most important problem. Because if you don't produce children, 3 years later, they will think that you're important. Even if you're not really interested, genuinely interested, they will start giving you. There is very good fertility clinic. Take this visiting card, go and meet them. You can't, sir, I'm not important, sir. I'm not interested in children. They'll say, stop joking. Better meet a good doctor. Is it clear? Maybe your sperm count is very less. Maybe that is why you're not able to produce. You understood? Due to society's pressure, people might really, get into sexual intercourse because they might have something to prove right here if they are very much influenced by the society. Is it clear? So cultural factors are a very big threat in countries like India, which force people to have children. Got it? Next is government policy. I think government policy I've handled in detail when we spoke about one-child policy in China. Okay, China is one country which forced people to get into the fourth stage of demographic transition theory, or where it can dictate have only this much amount of children. And please understand, government policy can also try to increase population. There is one policy, I'm not joking, okay. It started with an association with an airline company, I guess. The program was this: do it for Denmark. I'm not joking. Seriously, there was a program. Private company along with government, they started promoting. The birth rate is very, very high. So government can again encourage people to have more children if the population goes down. You take one-child policy in China, it was abolished. You know that, right? One-child policy is no more. Even Chinese government realized that they were too aggressive. So they said you can have 1+1. Now people are not ready for 1+1. They are like, one itself is enough. This itself we can't feed. Is it clear? And finally, migration. See, migration, I put it in bold because migration is related to everything. People migrate towards all these things. Is it clear? And that determines my population. Okay, that is the factors which determine population, distribution, and density. Is it clear? Now, next would be, okay, this is just a map talking about population density, that's all. Next would be my population pyramid. You take your half-an-hour break. See, there was an interruption. Because of that, I think we lost steam. And first part, which was supposed to be completed in 45 minutes, it went on till 1 hour 15 minutes, the climate section. So we'll need to continue. This will continue to the next section of class. Take a break for 30 minutes. Okay, we'll just continue right from here. Okay, 30 minutes. We'll meet again. So population pyramid is supposed to provide information on two primary things. Is it clear? So essentially, the definition is right there. It's information on both your sex structure and composition of population. So it works like this. Listen, x-axis is primarily divided on both halves into your male population and your female population. Is it okay? Y-axis, the decimals or the numbers will improve starting from your lowest numbers 0 to 9, 0 to 9, 10 to 19, 20 to 29, goes on till 60 to 69, 70 to 79 and others. You get it? So if you want to express your population, you express like this. So between 0 to 9 in a population, how many males are there? How many females are there? You get it? So between 20 to 29, how many males are there? How many females are there? Basically, so that is how you express in a population pyramid. Now the point to be appreciated here is, if on both sides, that is both sides of the pyramid, if you have equal male in population, it will be symmetrical. But if either your female population is less or more, then the pyramid might actually become asymmetrical. So that is one. Depending on asymmetry, you can understand whether there is any gender imbalance in the population between male versus female population. Get it? Second thing is, depending upon where the pyramid is actually bulging, is it bulging at the bottom? If it's bulging at the bottom, if it's much wider at the bottom, it means there is more young population in the entire region, possibly the city or the country. On the other hand, if the top portion is becoming much wider, then simply means it is having an older population. That is the meaning. So by looking at the population pyramid, which is an expression, you will be in a position to understand and appreciate what is the population character of an area. You got the meaning of this? So I'll proceed further and show you 4 different formats. I think at least the shape is clear. If not, you're able to read. You just look at the shape alone. I'll just tell you the 2 lines which are present right here. 2 lines. So this just indicates my 15 and 65. 15 and 65, that's all. See, I'll send the slides to you. I don't have any problem. My only concern is understanding it. You look at a pyramid, you should be in a position to understand what it is. These 4 things will tell you about the different stages of demographic transition. Think back again, stage 1. In stage 1, birth rate was very high. At the same time, death rate was very high. Is it not? Due to very high birth rate and high death rate, you look at your population pyramid, birth rate is more, which means young population is much more. The base is going to be much wider. Here is a wider base. Since death rate is very high, not many people get to live beyond the age of 65. So very narrow, very small top. Meaning makes sense. So stage 1 of your demographic transition. Stage 2, think back again, birth rate is still high, but death rate is declining. Death rate is declining. Is it clear? So in this condition, if you understand, you see that this base is still wide, of course, and it's becoming, it's getting segregated and moving up to the other age groups also. Now, the very narrow region is slightly getting wider. Okay, better dispersal of health services. So people are not dying as faster, so slightly becoming slightly wide. Not a very major bulge you find on the top, but slightly wide. Coming to stage 3, okay, so from a curved area, it has become a proper triangle. Coming to stage 3, you find your birth rates to be declining and your death rate to be low. Is it clear? This is the problem. Your death rate is low, not many people are dying, they are remaining. That is why the top is extensively seeing a very big bulge. You compare stage 1 and stage 3, you understand this was very narrow. Now, most people, even beyond the age of 65, will continue to be there. You want the understanding? At the same time, since birth rate is declining, this is kind of stabilizing. You'll see not a very wide rectangle, but some sort of a stabilizing rectangle. Okay, not as wide as the previous 2 cases, but something of a slightly smaller rectangle. Come to the final stage. Birth rate is low, death rate is low. So since death rate is low, the top portion is becoming even more wider. The problem is the bottom is becoming narrower right now. It's becoming smaller. which means people are not having enough children. So this is the trend which you see finally moving towards. You want to draw even a curve for Japan. Japan will look like a bulb. This one bulb. Is it clear? Fine. The young population or the child population will be very, very less. Old population is very, very high. So please note, if they ask you a question on population pyramid, don't change the format and anything. It's very simple. Same content of demographic transition theory. Just instead of stage 1, stage 2, this graph you put no. This one, birth rate, death rate. The space was there. Instead of this graph, what you do is, instead of this single diagram, split it into 4 diagrams, draw 4 population pyramid. The answer will be done. Okay, how population changes from a rural agrarian society to an industrial society. How does population growth evolve in an area? How does population pyramid change? Mains question again. You can just use this. Content is same. Diagram and format, you change it. There is no variation at all. Is it clear? Shall I move to the next one? Just let me know. Population pyramid, same as that. Not much of change. Except for the diagrams, nothing. Always be careful. Okay. Next, we are going to talk about life expectancy. Here also, same thing, life expectancy, total fertility. Let me finish this. Not much of change. Life expectancy simply means the number of years an individual is expected to live. Expected to live in a region. I again use the word region because can be defined for a country or a state also. Okay, number of years an individual is expected to live at the time of his birth. Number of years an individual is expected to live at the time of his birth. Life expectancy. Very simple. See, I think the colors are visible. Oh, red color, do you see here? Red color is higher life expectancy. They're given 80 plus. Is it clear? All the Scandinavian nations, think back to the map reading session, economic model we discussed, USA, Canada, and all of them. You come back to the lower, I think you'll find purple color variation, and this is found in Africa. Okay, and this is the lowest end of 45 plus, 50 plus life expectancy. Same thing demographic transition theory. Look at the diagram again. Yeah, look at the diagram. Here, life expectancy will be less because poor health facilities, poor sanitation facilities, people will die mostly due to communicable diseases itself. Children will die very, very faster. Okay, infant mortality rate will be high, maternal mortality rate will be high. Once you come to your demographic transition theory 4, you take countries like USA, Canada, your life expectancy is very high. People won't die of things like typhoid and cholera right now. People will die of diabetes, hypertension, cancer, non-communicable diseases will increase. Is it clear? You get the understanding? So this is again demographic transition theory. They ask you a question on how life expectancy varies in different parts of the world and what are the reasons for it. Write content from demographic transition. Certain countries are industrialized, certain countries are in stage 2, they're moving towards stage 3, and some are still stuck in stage 1. Okay. Based on that, again, you can write the answer. Got the idea? Communicable diseases, more infant mortality, more maternal mortality. Non-communicable diseases in stage 4, cancer, diabetes, hypertension. Okay. Less infant mortality, less maternal mortality, very good health infrastructure, extreme education infrastructure. That is why people continue to keep living. Simple. I'll proceed further. So life expectancy, same content. Last one. One more same content I will show you. Total fertility rate, TFR. Total fertility rates. TFR is the number of children a woman is expected to bear in her reproductive age. Expected to bear in her reproductive age. Okay. Reproductive age. See, the ideal means if you want the exact replacement level of population, the TFR should be at least 2.1. 2.1. This is the expected TFR for the population is to be at least exactly the same level, maintained at the same level, maintained and growing. See, please note, 2.1, it's not that the women will give birth to 2.1 children. Adalla. Average. Meaning makes sense. 2.1. Okay. Same story. See, dosa, masala dosa, ghee dosa, rava dosa. Dosa same. What material you add only will differ. Countries like United States of America, countries like Brazil, Argentina, Chile, countries of Eastern Europe, Western Europe, total fertility rate will be very, very less. They don't have much children. Again, demographic transition stage 4. Countries in Africa, Afghanistan, okay, Indonesia, it's very, very high. Your total fertility rate is very high, possibly 4 point something, 3 point something. They're actually in stage number 1 or stage number 2. Same content, total fertility rate will be high for stage 1 and stage 2. TFR is high for stage 1 and stage 2. But life expectancy will be low because poverty is higher. You come to the other side, stage 3 and stage 4, TFR will become low. Okay, because they move to a secondary sector and tertiary sector, cost of living becomes very complicated. So this is the variation. High TFR, low life expectancy, stage 1, stage 2, stage 3, stage 4 moving towards this direction. Life expectancy will increase, TFR will come down. That's all. Dosa, masala dosa, ghee dosa, rava dosa. Content is same. Depending upon the question, simply tweak the answer. That's all. Is this okay? Shall we go to the next topic? We'll move from dosa. All are same only. You just need to know how to connect and write the answer. That's it. Basic content won't change. That's the thing about mains answer writing. Sia KC 2035524. You have sent to 2 minutes. Okay, fine. 120 seconds. Why? Why 2 minutes? Make it fast, man. Graph. Which graph? Graph. Oh, this graph. This one. This one you're asking. This one. I think this is the only thing you're talking about graph. TFR is same as RFR. No. Replacement fertility rate is what you call as 2.1, where the population gets replaced. TFR is what is the actual value. RLF is your ideal condition, replacement fertility rate. Okay, fine. Just one doubt. Sia KC. Yeah, Karan, I will send the slides. I'll send to the academic one because tomorrow also I have your class. Clouds and this one I sent. See, Sia KC, what does KC stand for? Sia AN, I know. Sia AN means Anna Nagar. Sia OC means online. Sia KC means? Just asking, curious, that's all. Kumaraguru College, okay. I was thinking, what is Sia KC? Sia BLR is there, Bangalore, Sia AD is there, Adayar. I was thinking, KC, which city I was thinking in India? Sia DL is there, Delhi. Sia TVM is there, Sia Trivandrum. I was like, which city did they open a new branch? I was thinking myself. Kumaraguru College, okay, people. See, it's really nice that you're starting in college itself. That's good. That's really good. If I had started, I would have been better. Your bad luck, I am teaching you. Else I would have cleared and went. Let's talk about sex ratio right now. See, globally, the definition of sex ratio will vary. I'm just taking the Indian definition. So, sex ratio is defined as the number of females per 1,000 males per population. So, out of 1,000 males, how many females are existing? Is it clear? So, India's sex ratio, already know it is below 1,000, actually far for around 937, 939, I believe. That is the value. Now, proceeding further, Indian scenario, you'll see in Indian geography. I'd rather talk about the world scenario. See, please understand, you get two contrasting aspects. There are 3 continents in the world where sex ratio is actually more than 1,000. You understand the meaning? More than 1,000 means, okay, it's going to be greater than 1,000. It means in the population, number of females are more compared to males. But that's not the case with India. India, number of females are much less compared to males. So we just need to understand which continents are there and why do we have a contradicting scenario compared to Asia. You go to China, reverse. Same as India in China, same as India and Pakistan, same in Iran also. Asia, female population will be less. But you go to countries in Europe, continents in Europe, North America and Africa, slightly different. So we need to understand why exactly it happens. Fine. Why? Can anyone guess the answer? Why number of females is more compared to males? Africa, different reason. Africa will see the reason at the last. Europe and North America. What could be the reason? Number of females, population is more compared to males. Europe, North America, Africa. What could be the reason for Europe and North America? Say something. Anything. Cultural aspects, question mark. What culture? Do you think Americans have good culture? Huh? No idea. CIA and 2053577. I would have killed you, man, if you were in there in class. No idea. How can I say no idea? It's a society question after all. We'll go one by one. We'll understand the reasons first. See, actually, the reasons are not positive. Okay, usually I get feminism, women empowerment. Yes, those are answers. And no female infanticide, no female infanticide. Not completely wrong, but you need to hit the nail, as I always told you. Those are peripheral aspects and good to use in answers also. Please understand there are negative aspects which are to be added right here. Because female both is considered as asset compared to India, where female means dowry. Correct, that's a very good reason. No infanticide, again acceptable. High education acceptable. These are acceptable reasons. All are correct. We'll properly hit the nail right now. What? Yeah, one person gave the answer. 20239291. Good answer. That's one of the reasons. So three major reasons. First comes with reference to variation in life expectancy. See, please understand, life expectancy is generally more in continents of Europe and North America. But within life expectancy, do you know there is a variation? Within life expectancy, you compare females and males. Any country in the world, female life expectancy will be greater. Life expectancy will be greater than male life expectancy. There are three reasons for this variation actually. First reason comes from biology. The biological reason being, a woman's immune system is better than a man's immune system. Better when compared to a man's immune system. You know why? This is not true just for, please don't think this is for human beings. This is for all mammals. All mammals. It's a simpler reason to understand. Why would nature go for this bias towards women? Why does it favor women? The answer is simple. Females in mammals, they are the child bearers. They are the ones who propound the next generation. So nature itself decided they are the ones who give birth to the next generation, which means their immune system should be very effective in protecting them against diseases. Males, okay, fine, for reproduction, yes, sperms are needed, but they are not the ones who give birth. So nature itself decided variation in immune system. Females have a naturally better immune system because they are childbearers. Number two, see, there is a group of activities called anti-health activities. Antisocial is something, but anti-health is there. Example, smoking, drinking, rash driving. It's not that women don't involve in smoking, drinking, rash driving, but compare men and women. Disproportionately, men expose themselves to more smoking, drinking, and rash driving. You think rash driving is a joke, isn't it? I will show you one example. Wait, I don't want to erase the slide right now. I'll show you later. Rash driving. So because of this, there is more and more men getting dying in accidents, simply throwing their lives away, whether women are much, much safer. They're being sensible when it comes to these cases. Number three, see, first two at least it's okay. Third is a sad fact. Whenever I listen to this fact, my brain is really sad. Technically, the heart can't think. You know what? Most all countries in the world, you look at suicide percentage, people. Always men commit more suicides compared to females. The logic is, if men die because of poor immune system, if men die because of anti-health activities, if men die by more suicides compared to females, all the men die, automatically female population will increase in Europe and North America. That's all. Is it clear? Males are affected by non-communicable diseases because of their lifestyle. Madam. Similar to nitrogen content in atmosphere. Good observation. Very good observation. Good. CIN 2053577. This is a sad fact, people. Even the other two are okay. This is something sad. Is it clear? Coming to Africa. See, Africa, the reason is opposite. More and more civil war in Africa. And in civil war, you know who die more. It's males who participate in war more. So male population dies, female population increases. So Africa alone, the reason is different. Why many male suicides? Okay, there is a sociological reason for that. I will explain. Hold on. Civil war in Africa. Take this point. Before we go to the next topic, I'll just explain that. Why men suicide more compared to women. Actually, you know what? There are several countries in which, this is several, not few, several countries in which if 100 people commit suicides, more than 90 people will be males. Not even 10 women will commit. 90 men will commit. 90 plus. So before we go to industries, I think we are closing human geography soon. So just this idea between males and females. See, it's a paradoxical situation. Why there are more suicides? You take males, okay. Their social network is strong. Social network, no, not Facebook. I'm talking about the real life social network. Okay, stronger. But here social network is weaker. Fine, understand. Not just in developed nations, but mostly in developing nations, but it's present in developed nations also. You look at migration after marriage, it will be mostly women who are migrating. So once they migrate post-marriage, compared to males more, they lose their family circle, they lose their friend circle, their natural home environment which they grew up. So females will need to constantly keep moving post-marriage. Compared to males, they also migrate. Fine. But thing is, due to migration, females will lose their social circle. Social network is weak. Social network is strong. So question is, in spite of a strong social network, why would male commit more suicide? Well, the answer lies in human psychology. The answer is, even though social network is strong, they do not share their personal worries. Is it clear? Like there is an imposition that man shouldn't, you're a man, you're not supposed to do that. You're not supposed to sound weak. That's a psychological, it's more of a social reason, which kind of concern, or there is a proper iron cage where a steel personality you need to maintain, you're not supposed to reveal to them. See, think about, this is for men, this question, who are participating in the discussion. Think about, you'll have a very small group of close friends. 5 stupid friends will be there. They'll come till your death. Even though they're stupid, they are friends. And think of the last time a friend came to you and cried, he should be crying his shirt everywhere. He's like, everything is gone. That kind of feeling I'm saying. Not while he's drinking, other stupid type of crying. He'll be repeating the same thing over and over again. I'm talking about a serious situation. He comes to you, he cries, he says there is absolutely no way, there is no solution. If you think rationally, last 10 to 15 years, you think, starting from your school, it doesn't matter. You would actually think that you would not find even 2 or 3 incidents, 3 major incidents where a friend came to you and cried desperately. We have a serious problem, except for some stupid people who drink. I don't care about them. They do it every time. Even in serious situations, men don't pour out their personal things. Here, no. Here, small problem will be there. For one shirt to one top, one exact matching chudidar, that some dupatta won't be there, some pant won't be there. Regarding that, they'll speak for 15 minutes. For this problem, means serious problem, they will pour outside. It will come pretty. Okay. Whenever I call my mother, I call my mother, that's all. I just listen. Complain about father, family, me, you are not doing, you're not a good son, you're not working properly, not clearing exam. Okay, fine. Father, only 2 minutes talk. Saptiya. Saptiya means eat. That's all, done. That's it. You get it? See, naturally, they have this tendency to share a lot of things, okay, with their. So it doesn't matter even if they have a poor social network, they'll share their poor things out. They'll try to keep it inside. They try to keep it inside. At one point of time, if they don't find anything to share, it'll explode. The explosion happens internally and the suicide. They don't keep it in. They just pour it outside. You get it? Now the understanding why many males suicide in spite of another paradox. Network is strong, but not sharing it outside. Life is full of paradoxes, right? India is a paradox economically, because even though we are a tertiary sector economy, largest population still working in primary sector. Think back to discussion on primary, secondary and tertiary sector. Primary sector is anything which is associated with products produced from nature, directly from map reading nodes. Secondary sector, the product which is derived from nature needs to undergo one more level of processing. Tertiary sector will support both primary sector and tertiary sector. Primary sector and secondary sector. Banking, insurance, manufacturing, and this is agriculture, fishing, mining, etc. Got the difference? Now just recollecting, I don't have anything to speak on this. We need to understand something regarding industrial location. Certain things are self-explanatory. Please note, there is nothing to really talk about industrial location for primary sector. Where will you fish? Where fish is there? You can't fish in desert. Meaning makes sense. Where will you mine? Where minerals are there? You can't search for oil in center of Tamil Nadu. Central Tamil Nadu, Madurai, Tiruchi, oil is not there. You go and search, nothing will come. You go to at least Kaveri Delta, hydrocarbons are there. But now we have protests in the Kaveri Delta region. You get it? So primary sector is straightforward. But when it comes to your secondary sector, your manufacturing, your industrial location, there are several factors which affect them. There are both geographic and non-geographic factors, and that is what we see in the next slide. Is it clear? Please copy this in your notebook, even though I'm giving you the slide. Please take this down. Factors which affect industrial location. We will use this in climate. Okay. Raw material, market, labor, power, land, transport, agglomeration, forward and backward linkage, government policy, research and development. All are self-explanatory except two. These two I'll explain. When we go to climatic regions, I'll tell you how to write answers. Okay. Raw material, markets. Labor cost should be cheap. There should be 24/7 availability of power. Land cost should be cheap. Government should enable proper regulations. There should be proper construction of infrastructure, be it your roadways, railways, or airways. Agglomeration, forward linkage. Government policy specifics like special economic zone we saw in China. Okay. Research and development. Okay. They tells your innovation, invention. Finished. Okay, fine. Thank you. So two things don't require explanation. What is agglomeration? What is forward and backward linkage? So inputs on agglomeration. Just the basic idea. See, several factors of production. Note this down, I'll explain. Several factors of production enable the concentration. Enable the concentration of an industry in an area where production cost becomes cheap. Where production costs become cheap. We'll understand. Hold on. See, agglomeration is a phenomenon which we experience in everyday life. Like every day you experience it. You visually see it, but we don't appreciate it. See, all the other factors, starting from raw material, markets, labor, power, land, and transport. A combination of all these factors in certain locations will become cheaper. And over a period of time, it is much easier to start an industry in an agglomerated zone rather than starting it outside. I'll give you one example. You can be in any city right now. Okay, you can be in Coimbatore, Madurai, you can be in Delhi, Trivandrum. Just think about one thing. In your city, where you are, there will definitely be an area which is known for electronics. Want to purchase electronics items, they will tell you go to that location. Definitely one place which is known for textiles. For example, in Chennai, textiles, they will tell you go to T Nagar. Electronics, they'll tell you go to Ritchie Street. There is a place. Is it clear? Now I told you the electronics, no? Like Ritchie Street in Chennai, in your area, there will be an electronics area. Electronic shops will be concentrated in one zone. Think back again, in that electronics zone, which is present in your city, if you think about which shop, people will not be able to say. They will simply tell you electronic related items, you go to that area, man. You go to that area, all shops are there, only they will give you commodities. But if you ask them the name of the shop, they wouldn't know. You get the meaning? Because in that region, from the initial condition, land was available. Labor cost was very, very cheap. You get it? Market availability was there along with raw material. When all the factors combine together, over a point of time, each factor will reinforce each other. The region will get an identity. Is it clear? Meaning is, in this Ritchie Street or the zone known for electronics, in your city, similar to Ritchie Street, you'll have your own location. Instead of, so if one entire area is there, several factors will enable the operation of or the development of one agglomerated zone. The point is, rather than starting a shop, 10 by 10 shop, okay, quite big, in some other area, if you start a small shop, maybe 4 by 4, 4 by 4, not this much only, you start a small shop in Ritchie Street, an electronic shop, this will be more successful compared to this, because in this area, every cost is low. People will come to the region expecting a particular commodity, and if you're producing it, your company will grow. You understood the meaning? That is agglomeration. Read the fact again. Several factors of production enable the concentration of an industry in an area where production cost becomes cheap. You want even an easier example? Think about traveling in a highway. How many times has it happened? Every time you travel on a highway, you wouldn't find a petrol bunk for 75 kilometers. All of a sudden, 2 petrol pumps will be together. Inside a city, same, not a highway, in the city, same thing. You'll be moving for a long time. Hotels won't be there. Suddenly, 4 hotels will come. Stupid people. 4 hotels will be there, isn't it? Along with the 4 hotels, one person will be selling toys outside, one person will be selling shirts outside. Because he knows people who come to the restaurant would like to buy something. Cafe, coffee day will be there nearby. To understand the meanings, you understand that is agglomeration. Factors will reinforce each other. So rather than starting the industry outside the agglomerated region, start an agglomerated region. Even in smaller size, your business will grow. Got the meaning of agglomeration? So now I'll go to forward and backward linkage. Is it clear? Forward and backward linkage. We'll take railways as an example, then write the definition. See, supporting an industry can do 2 things. It can either develop the industries which are dependent on the industry, or develop the industries in which the industry is dependent on. You got the difference? Let me put it with railways. If you want to construct railways, if you want to operate proper railways, several things are necessary. For example, you need iron and steel, engineers, and metal. Is it clear? Electronics, electricals, all those things will be needed. Only if all the materials are there, you'll be able to operate railways. Think carefully right now. If you want to promote railways, if you promote railways, automatically this will create demand for all these industries. Now, these industries provide the raw materials which is required for operation of railways. This is backward linkage. You get it? You, by developing one industry, you are supporting the industries which make the industry in the first place, which make railways. That is backward linkage. You're going back to the source region. At the same time, let's say that you want to talk about one more industry which is dependent on railways. Example, coal. Transport, water. Coal is something which is highly transported by railways. We can take, people traveling also. Example. Let's say you're initiating bullet train project. Normal railways, the speed is increased by 15% or 25%. Now, if railways move much, much faster, you increase their efficiency, coal transport will increase. Once coal transport increases, coal industry will move up. Listen carefully. Coal is not providing raw material in this case. Even though thermal railways, we have moved to electricals. The point is more transportation of coal. Due to more transportation of coal, coal industry will move better. People transport is increasing, so people's efficiency, instead of 8 hours, you move a person in 5 hours, he'll be reaching a short span of time. So he is much likely to use railways again. Either forward linkage. So these are industries which get propelled due to better operation of railways, but these industries will provide the raw materials. Hence, if railways grow, the raw material industries grow. So this is backward linkage. Backward linkage. Either forward linkage. Either means this. Okay, non-thermal speakers. See, you can replace the word railways with automobile. Automobile, so many branches will be there. We saw with SEC. You can replace it with infrastructure. Bridge construction, you think? Bridge construction is very good. Road infrastructure is very good. If instead of the pothole roads we are having, if it is very efficient, people's efficiency will increase. They won't get that much tired. You understood the meaning? That is why economists always say, you write in newspapers, right? People say you need to invest in infrastructure, railways, roadways, because you boost infrastructure. Infrastructure gives you both backward linkage and forward linkage, where all industries will develop. That is the logic behind it. Meaning makes sense. So shall we move to the last point? Settlement zone, I think, is there. Others you see one by one, like every climate you go, you'll get reinforced. Just let me know. One response. One person has asked for definition. Okay. Thought I'd given them. Supporting an industry. Propels the industries dependent on them. Industries dependent on them. This is forward. And the ones on which it depends. This is backward. Railways depends on it depends. So this is backward. Railway depends on electricals, railway depends on electronics and all others. Dependent on them, coal, people movements, everything. Transport of goods and services, that's all. Supporting an industry, propose industries dependent on them, forward, and the ones which on which it depends, backward. Forward and backward linkage. Learn this in economics also. KC 2055, I think you're okay? Yeah, fine. Proceed for the last part is, I think, settlements, and then hold on. This segment is not needed. This is what I'm concerned about. Yeah. See, urbanization and urban settlements, it's specific to certain climatic regions. Rural settlements is required. Some terminologies require explanation. Is it clear? See, thing is, when you talk about different types of settlement, we are just concerned how closely your houses are getting spaced. Meaning, you can, if you have a field, are my houses very close by, or are my houses very far away? That's all. This is nucleated or compact type of settlement. This one, I think we can understand, houses are generally spaced far away. This is dispersed type of settlement. Okay, where there is large distance between two different settlements or two different homes. Okay, if the houses are closely spaced, you call it a compact settlement. Can we use the term forward and backward linkage as upstream and downstream? Yes, you can. like forward and backward linkage, we used it because that's something which comes in newspapers and it's an economic terminology. Only for that. GS3 you'll learn again, general economics. After core economics is over, we'll be teaching you that. Okay, because I also need, he'll also need, that's why we introduced. So where do you get compact and nucleated settlement? That's what I put here. Fertile plains. I think this makes more sense because in agriculture, in one field, it is not one individual who's working. You need a larger group of people. So large number of them work. That is why you'll find many houses together. Is it clear? Compact. Mountains. Why mountains again? Mountain settlement is compact because of security. Security aspect. There is more exposure chances to wild animals. And only if you stay together, very good chance you can fight against wild animals. Number 3, fishing communities. See, fishing communities, same reason as fertile plains, but we don't realize it. Just like how agricultural lands need several individuals to work in tandem to really till the land and work on land, fishing communities, think about how difficult it is to push one boat inside and then bring the boat back again. You need at least 8 to 10 individuals for operation of boats, taking them to the sea, again coming back, either to the lake, again coming back. So you need a society, you need a community to operate. That is why fishing communities, again, compact and nucleated. Is it clear? And coming to the last one, dispersed is found in extreme climatic conditions. Okay, be it deserts, be it steppe climate. Steppe climate is one where you will see this. Steppe climate, I'll give you an example in the central USA, where the spacing between houses is very, very far away. Is it clear? So that is the end of human geography discussion. And the reason we introduce this is every climatic region I go, I'll be finishing small segments of human geography along with distribution of key natural resources. So this is the input which will be elaborated even further. Now I'll need to take you to physical geography again. We're going to look at atmospheric pressure. Ready for pressure and wind system? Global atmospheric circulation. Sandwich today, physical geography, human geography, physical geography. I'll send you the PPT, batch 3, right? I'll tell them to forward. Clouds also, but clouds, nothing is there. There's only pictures. Right, that ends the discussion right here. So go back to a blackboard, sandwich, physical geography. Now we're going to look at atmospheric pressure, basic. Pressure exerted by a column of air. Exerted by a column of air. Raj, for your batch, today is October 16, 17, right? November end. See, tomorrow, next weekend, we'll try to come back. So November end, I think we can wrap up. I mean, I'm talking about world geography syllabus. Indian geography need to take some time. I'll finish world, only then Indian geography will start. So keep November end or December 1st week in mind. I think by the time your batch will be wrapped up. See, world geography, I've done 6 to 8 sessions of math reading for you. And world geography will be enormous. Indian geography will be very simple, application only. Indian geography, nothing will be there to learn. Is it clear? Pressure exerted by a column of air. Again, when we use the word pressure, you will automatically get this definition, force per unit area. See, try to visualize pressure rather than simply seeing it as force per unit area. See, please understand, pressure, you can simply understand it by talking about weight per unit area. For example, this chair won't be visible, I think. For example, we take this chair. Right now, no one is there, isn't it? Now I sit on this chair. I'm actually putting weight on this chair. That's all. Is it clear? So in the previous scenario, there was nothing over this chair. Fine. So when you put weight on it, you're adding weight per surface unit of this chair. So visualize pressure as simply weights getting added. So this is a high pressure system over the chair. This is a condition of low pressure system over a chair. Again, high pressure system over the chair. So when an air column sits down over an area, you get an intense amount of high pressure. And when air is going to rise up, you clearly see that pressure is getting released. So sitting down, column high pressure, getting up, low pressure. Meaning makes sense. Okay. So visualize it as weights. Okay. Now, what we're going to understand before we move to high pressure and low pressure is this. Well, let me draw that for you. And then we'll go to pressure variation. So sitting over an area and descending down. Okay. If I blow over, you see that air is punching the surface. So this is high pressure. On the other hand, if air raises up and air leaves the system, this is a low pressure condition. Is it clear? High versus low. High and low. Got it? Now, second thing is, how will atmospheric pressure vary between different altitudes? So please note, wherever you are right now, okay, let's say you place your hand. Is it clear? And for per unit surface area of your palm, you try to measure atmospheric pressure. Let's say you're standing in first floor. Now, what you do is, you go to ground floor of the building, wherever you are. Again, put hand. People will put money, but that is different. Focus on the task right now. What you do is, first condition in first floor, you measure atmospheric pressure. How measure atmospheric pressure is, from here go to troposphere, stratosphere, mesosphere, exosphere, ionosphere, everything together. The entire atmospheric column is going to put some weight over your hand. No, that is atmospheric pressure. Got it? Now, you measure atmospheric pressure here. This is ground floor. This is first floor. Where will atmospheric pressure be more? Ground floor or first floor? Make mistake, no. One person still made a mistake. Maybe didn't get the question. All of them are right. Very good. One person wrong. I asked, where will atmospheric pressure be more? Ground to floor. See. Extra column is getting added, no? You come here, this much extra, some simple concept, this much extra weight is there, that weight will get added. See, that's why you understand, with increase in altitude, atmospheric pressure will decrease. Why? Air column size you are cutting down, no? With increase in altitude, atmospheric pressure will decrease. Pressure decreases. Decreases. Is it clear? Increase in altitude, atmospheric pressure decreases. Extra weight is there. You keep on moving, you're cutting the column. You're like, leave this extra weight, we'll measure top. That's it. Now we're going to talk about wind system. And from wind system, we'll go to global atmospheric circulation. Properties of pressure will definitely, time should be there. I'll finish it today. Equatorial possibly will start tomorrow. There was a video interruption and time lag. That's why we had to hold on. So now we'll enter winds. So winds are a result of advection. Advection means horizontal transfer of heat. So it is the horizontal movement of air. Horizontal movement of air. Movement of air. And is governed by three forces. Three forces. Number one, pressure gradient force. Pressure gradient force. PGF. PGF. Frictional force. Frictional force. FF. And finally, Coriolis force. Coriolis force, CF. Is it clear? So three forces combine together and finally influence the direction and magnitude of the wind. We'll continue right now. So 3 forces combine together to produce your final resultant. So we'll start with the first one, then we'll go to the third one. Third one is slightly complex. Starting with pressure gradient force. Yeah, pressure gradient force. It directs winds. It directs winds from high pressure to low pressure region. From high pressure to low pressure. Look at the word right there. Gradient means slope, that's all. Just like a ball moves from the top of the mountain to the bottom, due to the presence of slope right here, this slope, gradients, there is variation top to bottom. Similar to that, from a high pressure region where air is descending down, right? Low pressure region where air is rising up. This yellow color line will be my pressure gradient force. This one, wind blows from high pressure to low pressure. PGF, pressure gradient force. That's point 1. Point 2 right now. The higher the pressure difference, higher the pressure difference, the stronger the PGF. The stronger the PGF. I think this makes sense. The pressure difference is very, very strong. One place it is 1000, one place it is 995, one place is 1000, one place is 985. Difference is more space is there. When air rises up, more space there, I'll immediately go and occupy. I'll go and sit there in this area. That is the purpose of pressure gradient force. Is it clear? So 2 fundamental points. Wind blows from high pressure to low pressure. Pressure difference is more, pressure gradient force is stronger. That's all. Believe you got it. Simply straightforward. Second is also fundamentally easy, called as frictional force. Okay. Friction, number 2. Proceed further. Think you're done. Good. So moving to second one, frictional force, FF. So this is the resistance. This is the resistance between the wind and the surroundings. Wind and the surroundings. Simple example. Mountain is present. Buildings are present. Okay. Trees are present. Is it clear? When wind moves from one direction to another, you think the wind will be able to sail smoothly. The building will influence the direction. The mountain will influence the direction. The tree will influence the direction. So because of the presence of several surface variants, the wind will definitely get obstructed. See, friction can do 2 things. It can affect the velocity also. See, wind is blowing and you block it, you provide resistance, then automatically the speed will decline. At the same time, it can change the direction also. Direction also can get changed. Is it clear? So both velocity and direction, similar to pressure gradient force, will be affected. Is it clear? I was just scrambling for this. Compare and contrast pressure and temperature differences with respect to altitude at end of class. Ma'am, there is no complication. With increase in altitude, both temperature will decrease, both pressure will decrease. See, please, in the P, I'll tell you. Sorry, I'm not blocking anything, no? PV by T is equal to constant. Throw that formula outside geography. The relationship which you study as Bernoulli's theorem, Charles' law, Boyle's law, Gay-Lussac's law is applicable under conditions of laboratory, not applicable in nature. Please throw those things away. Don't get confused between temperature-pressure relation, what will happen. Leave that. Just leave that, okay? Inversely proportional, directly proportional, those things you leave. Understand rationally. There is no confusion at all. With increase in altitude, temperature is decreasing. Why is temperature decreasing? Because more density of greenhouse gases, because of greenhouse gases, heat is more. Once you move away from the heat source, temperature will decline. Now, gravity is very, very high. Large number of air molecules. With increase in altitude, you're moving away from gravity. Automatically, air column you're cutting. You're measuring pressure here. Only this much air column pressure you're measuring. This level of pressure you're not measuring. With increase in altitude, again pressure will decrease. Don't make this relationship, your pressure, temperature. This is logic. This is also logic. Never ever use your formula from your chemistry textbooks. Is it clear? You look at the chemistry textbooks again, it will be under conditions. At constant volume, pressure, temperature relation. At constant temperature, pressure, volume relation. In nature, how will you do that? Not possible. With increase in altitude, both temperature will decrease because moving away from heat source, pressure also will decrease. And the size of the air column you are cutting. This much only I am measuring. Pressure will be less. Now move to the third one. Write this definition. See, this discussion is not given in NCERT, no textbook properly. Coriolis force. Number 3. It is an apparent, not real, apparent force which directs winds, sorry, not directs, I'd rather use this word, deflects, that's the most important word, I'll highlight it properly, which deflects winds to the right side in the northern hemisphere and left side in the southern hemisphere. Apparent force which directs winds or deflects winds to the right side in northern hemisphere and left side in the southern hemisphere. Now I need to tell you something very important. Okay. Most important word in the definition is this. See, there is nothing exactly called as a force acting. That is why I've clearly given it is a not real phenomenon. There is a deflection, just a deflection. It is caused due to rotation of the earth. That I'll write it here. Caused due to rotation of the earth. Rotation of the earth. Thing is, you'll need to incorporate the Coriolis force due to rotation. If you don't take Coriolis force into account, it can lead to several miscalculations if you're talking about a global travel phenomenon. Is it clear? We'll see examples. Before I start, I need to get something from you. Cause due to rotation of the earth. No, wait. Rotation of the earth. That's all. Those 3 words will be fine. Listen. All you need to remember is Coriolis force, northern hemisphere, right side. If you know this, this is more than enough for cracking your exam. More than enough for cracking your exam, na, this itself will be enough. It is not necessary why Coriolis force in northern hemisphere is right side. If you know this, you can get an exam. Is it clear? I will try my level best to explain why. If you understand why, good. If you don't understand also, very good. All you need to know is Coriolis force, northern hemisphere, right side. Is it clear? Shall we start? So this explanation, I'm not going to dictate anything. You want, you can write on your own. I'm not going to dictate anything. I'm just going to explain. This is not required for exam, but I just want to give you clarity. That's it. If you understand it, good. Don't understand, very good. Only thing you need to memorize, Coriolis force, northern hemisphere, right side. That's it. We shall begin. Don't ask me to repeat this again. I will kill you. Okay. Because not required. I just want to drive my point home. We're going to take 2 concepts and combine both the concepts. That's all. First concept 1. Tell me whether you get this idea. Every one of you know the merry-go-round, right? If I tell merry-go-round, people will say they've never seen it in their life. Let me show you a photograph. One person will come. Sir, what is that, sir? Is it a planet? They will ask me. Ama, planet. Rotating. People are there. You don't know. I am only with the chat box. No, they will come. If you remember this, your childhood was awesome. They'll put that meme, no. Merry-go-round, now you understand. Kindergarten, you should have played. Not played, now you've wasted your life. Merry-go-round. Is it clear? Now, in the merry-go-round, we'll take two conditions. Condition 1, you're sitting in the extreme, right here, exactly where the seat is there. Condition 2, you're sitting very close to the center. Okay. I will rotate the merry-go-round. Picture yourself in both these conditions. Condition 1, extreme seated. Condition 2, simply sitting close to the center. Between 1 and 2, when will you experience maximum speed when I'm rotating? When I rotate, when will you experience maximum speed? Where will you experience maximum speed? 1 or 2? If you've played, you know the answer. Now correct answers are coming. Very good. Okay. 1 only, because the more and more you move away from the center, velocity will be maximum. Centrally, you won't feel that much speed. This concept is clear. See, this can be applied to Earth. How means? Earth is a sphere. See, same diagram. Earth is a sphere, we'll draw. Central axis is there. And the extreme circle I told, no, the circle is equator, people. Think back to parallels and latitude. From the equator, you either move to the northern hemisphere or to the southern hemisphere. Length of the line will decrease. So this will be very, very small. Maybe this is 60 degree north. Is it clear? You compare your Earth between your equator and your 60 degree north circle. You compare velocity. Is it clear? When Earth is rotating, equator will have the maximum velocity, very, very fast. Okay. Compared to equator, 60 degree north will be slow. Why? Look at the diagram again. 60 degree north is close to the center. Velocity will be slow. Equator is very far away from the center. This is similar to sitting in extreme position. This is 1, very fast. This is 2, very close by. You get the understanding? This is concept 1. If you understood concept 1, if you're ready, give me the word finished. I'll go to the next topic. V is equal to R omega will come. Will come. V is equal to R omega. Still you remember, very good. Concept 2. Simple concept. Don't think too much, not complicated. Make mistake means you see. One cricket ball, some small ball. I'm connecting with rope. One condition, I'm connecting with a small rope. This is condition 1. Same ball, same cricket ball. Second condition, I'm connecting with a lengthy rope. Very lengthy rope. Condition 2. Now, after connecting both of them, I'm starting to rotate. Is it clear? Listen to the question and answer. Make a mistake, I will kill you. When I rotate, condition 1 or condition 2, in which case will I be able to rotate faster? 1 or 2? One wrong answer will come. No. All are correct. Oh, very good. All of you giving the correct answer. It will be 1. Common sense. Rope is small. You take the mask. Rotating very fast. The length is very, very less. Is it clear? You take the very lengthy one. I'll have to put like short put. Won't be able to complete one rotation at all. Concept understood? See, the idea is, this is the concept of conservation of angular momentum for a mass. Don't get afraid. Not required for exam. Saying conservation of angular momentum for a mass. See, for a specific mass, mv equals mr omega. That's all. Wait. Simple. Concept, you understand this alone. If the radius is small, angular velocity is high. Radius is very lengthy, angular velocity is low. This you understand, it's okay for me. Got it? Radius small, angular velocity high. Radius is high, angular velocity small. Once you've understood, give me the word finished. I'll go to the next one. Finished. Very good. Every batch. Concept 1, did you understand? They will say, yes, no problem. Concept 2, did you understand? Yes, no problem. When I combine, all of them will come. Sir, did not understand. If you say that, I will kill you again. Listen, C1 and C2 combination. Under a scenario. Now, before this, I need to get a confession from you, whether you can understand. Yeah. See, picture this. Picture myself traveling to different cities. I'm in Chennai. Chennai is not that far. I'm in Chennai. From Chennai, I moved to Nairobi. From Nairobi, I moved to Moscow. Moscow, I moved to Melbourne. From Melbourne, I moved to Buenos Aires. From Buenos Aires, I moved to Washington, D.C. Washington, D.C. to, where should we go? Paris. Is it clear? The thing is, when I keep moving across different cities, you clearly see that I am in different parallels and latitude. You get the idea? Listen again, when I keep moving between different cities, the area or parallel where I'm standing is actually changing. See, please note, when I move in between any parallel, any latitude, when I am moving, I am changing the radius of rotation with the equator. Meaning makes sense. I am an object who's standing on the earth. So when the earth is rotating, I am also getting rotated by the earth, isn't it? So I am like a ball tied to the axis of the earth like a string. Is it clear? So when I move, the radius to which I'm connected will keep on changing. I think you got this idea because I am an object on the earth. I'll proceed further. You should get this. Let's combine both of them. Scenarios, this people. Scenario is, I'm going to make a jump. Jump is from 60 degree north, possibly here. Okay. Possibly here. From 60 degree north, close to Moscow. From Moscow to Nairobi. Nairobi is in equator. This is me. I'm going to jump to a chair right there. Maybe they have a bed in Nairobi. I'm going to move from here to here. Is it clear? First, let's take concept 1. My destination, listen carefully, my destination circle is equator. Destination circle equator has higher distance from the center. 60 degree has not lower distance. 0 degree, which is at the equator, is my destination. Here, the circle is fast. Destination circle is moving fast. Is it clear? This is concept 1. Just now we finished. I did not talk about me at all. Still now I haven't talked about me. I'm just talking about equator circle. Faster compared to Moscow circle. That you understood? No. Concept 2. Now I'm going to talk only about myself. I'm not going to talk about the equator. See? I'm an object. I'm going to jump from 60 degree north to bed in Nairobi. Correct? See, when I make the transition, I'm going to jump. When I make this transition, if you think about the object's radius, objects, I am the object here. I am the object rotated by the earth. The object is going to move, and when the object moves, the radius is in object's radius, earth radius, object total radius, the area, how it is connected. Slowly the radius is increasing. My radius is increasing. I am increasing the radius. Radius is increasing. If the radius increases, just now we saw according to concept 2, what happens to my angular velocity? Velocity will decline. Object will become slow. See, intention is, I am not intentionally becoming slow. I am simply jumping from here and there. Due to increase in radius, it's becoming broader. Increase in radius, automatically my velocity will decline. Got it? We'll climax see. Bed is there. Concept 1 and concept 2 combine. Bed is there. Is it clear? Bed is moving faster. Earth is moving, rotating from western side to eastern side. Bed is moving faster. Object is there. Object is becoming slow. Simple question. Bed moving, I am coming there. Object is moving slow. So will I catch the bed? 3 options. Will I catch the bed properly, or will I go to a location before the bed, or will I go to a location after the bed? You tell me. 3 options. First, catching impossible. Will I go to location before the bed or after the bed? Very good. Good answers, good answers. Logic. Bed is very fast. Bed will go somewhere. I won't, sorry, I won't catch the bed. I'll go to a location after the bed. Listen, so when I make this jump, I can't catch it. I'll go to a location after the bed. That is why we use the word apparent force, not real. No force was acting. Due to rotation, there is deflection. Coriolis force, northern hemisphere, right side. Immediately one person will come. Sir, this is left side, not right side. I will kill you again, man. Listen carefully. Right side and left side is not based on your perception. Right side and left side is only directed based on the source observation. You want an example for that? Simple. You have confusion on right and left. Put your right hand outside. Just put your right hand out. You see that? My right hand side and your right hand side won't be same because we are in the opposite direction. The arrow is coming from the opposite direction, so its right hand side will be different from your right hand side. Got the meaning? So in case if the motion is like this, then you can say it will be moving towards the right side because this arrow, the upward arrow's right side and your right side will be same. So never ever get confused on right side and left side. It is always right side in the northern hemisphere. There is no problem to get confused at all, but don't make mistake. Right side, not your right side, source or the right side. Is it okay? Now got the idea how Coriolis force deflects. Okay, fine. I want to add one more layer. Second layer is very easy. See, this is applicable for north to south movement. Immediately what question will come is, sir, is it applicable for west to east movement also? West to east, now this is the idea. See. So if I say this to north to south, you'll understand, okay, right side. Right side, you'll understand. South, north to south, south to north, you'll understand, okay, fine, this is right side. Question will immediately come to your mind, sir, what will happen if will Coriolis force act if I move from western side to eastern side to western side also? Will there be deflection? The answer is yes. Okay, further we'll see an even simpler example. This complication, everything is not required. It will act in western side to eastern side also. Okay, only direction where it won't act is if air is vertically rising up. Wind is horizontal movement. Simple example, you take this globe. என்ன அரவிந்த் இது half size பண்ண முடியுமா? இல்ல வீடியோ டிஸ்ப்ளே half இருந்தா போதும். Okay, thanks. Yeah, this is fine. See, we'll forget India. You see Africa? Where my index finger is there, the Africa is there. African continent. See, thing is, when Earth rotates from western side to eastern side, Africa won't be showing the perfect location. You get it? Africa will first show its side. You see the side of Africa, eastern side of Africa will come. Then Africa will perfectly place itself towards the center. After placing towards the center, then it will move out, no? You see the western side of Africa, not the entire Africa. See, this kind of rotation, so only eastern side, complete center, only western side. Africa won't be moving like this. Like this it won't go. It'll come like this. Only in the central position you see then it'll go like this. What the meaning? Basically, so if I'm a human, nice. If I'm a human, I won't move like this and all. Dalla. First I'll show the side, then center, then show the side here. Okay. How they take photograph for criminal. See, we'll take India. Gujarat reference, Kutch and Kathiawar Peninsula. So India will show left side. Just now we saw, no? Like this. Then India will properly stand. Properly standing. Then India will go away. This like. Western side to eastern side, Earth is rotating. I will draw a line to indicate the position of Kutch and Kathiawar Peninsula. Gujarat, perfect reference point. Two triangles are there. Okay, this is Kutch Kathiawar Peninsula. Now I'll draw wind direction. This is green color line. See, understand, wind direction will be same. It's not going to change. See, wind direction, wind direction, wind direction. In this entire process, wind direction I have drawn in the same line. But look at India. due to shape of the earth, due to spherical shape of the earth, during rotation, India moves like this, right? So because of that, it seems to apparent movement, not real. It seems to experience a right side deflection. Is it clear? That is why western side to eastern side or eastern side to western side also, Coriolis force will act northern hemisphere right side. Western side to eastern side because shape of the earth. It's a sphere. Got it? I think the blue color line is reference line, Gujarat. Green color is my wind. Wind will be constant. But since reference is changing, it will seem to get deflected towards right side. Got the idea? If you understood, good. Did not understand? Very good. Coriolis force, northern hemisphere, right side. This one you remember. That is enough for me. That's all. Tell me whether you're finished. I'll proceed further. I'll give the when did we stop? 5. Oh, I'll need to give you a break. I'll give an example and then I'll give you the break. Just one example. I totally forgot about break. Good thing I remembered. Didn't get this part. Now, understood? Good. Did not understand also? Very good. Maybe last we will see. Don't worry. Okay. See, example, the reason why you need to understand this is, let's say United States of America and India is having a problem. It will come. India are having a problem. USA launches intercontinental ballistic missile with nuclear warhead. The person who's launching the missile need to undertake Coriolis force calculation. If he's not taking Coriolis force into account, right side deflection, right side deflection, instead of coming and hitting India, it will go and hit to Pakistan. Pakistan will be dead. See, whenever a large object makes movements on a continental scale, like missiles, like aircraft, they need to take into account Coriolis force. If we don't take them into account, then haphazard will happen. If we calculate Coriolis force properly, that's all. Is it clear? Will any mains questions be asked on this topic? Not from Coriolis force, but you will get mains questions on the topic which I'll be discussing after this. Global atmospheric circulation. In that it will come. Okay. See if it is not required. That's why before explanation itself I told you. Fine. Yeah. 5 minutes break. SEIN 2066057. See, actually, we haven't stepped into it at all, to be honest. The topic which we're going to discuss right now will be the most important climatology topic. Once I finish the properties of pressure belt, at least I can show you. Is it clear? Okay, so no problem. We'll see. Give me at least a few more days. Like tomorrow, not possible. Possibly the next weekend. See, this segment, I don't know, like 22 people have left, I believe. Yeah, 31 it was. Now it's 29. If they don't understand this, they won't. There is no point in coming to climatology class ever. See, next to 35 to 45 minutes, after which I'll take doubts. This is the most crucial section of climatology. Is it clear? If you understood this, then climatology is nothing. You don't understand this, you skip this, then even if you stand upside down, you're not going to understand climatology. Okay, global atmospheric circulation. The most important part. This is the foundation for both your prelims and mains. Mains especially. Global atmospheric circulation. We'll start from history. We'll finish the entire discussion and we need to hold until 7:10, 7:15. Only then we'll get the entire picture. We'll go one by one. People have been fascinated by wind systems, but wind systems had a more historical relevance only after 1492. Especially in 15th and 16th century, when the African slave trade was booming, Europeans had to understand the wind system. Later, for navigational purposes, when it becomes extremely exemplary, people invest in engineering, people invest in meteorology also. So how does the atmosphere circulate and why do we have wind systems at the surface? One of the earliest theories provided to explain the Earth's wind system was given by one person, George Hadley. So we want to understand how the atmosphere's large-scale wind system really operates. First model is given by a person, George Hadley. I'll write his name later. First, you'll understand the diagram. Okay. George Hadley. So he is the first model and how the atmosphere is actually going to circulate. And let's try to understand what we are drawing first. This is my Earth, 0 and 90. Okay. So what I'm going to do is, this 0 and 90, this vertical scale, I'm going to put it flat. We've done it for temperature. Forget southern hemisphere, we'll talk about the northern hemisphere, 0, 90. What you find in northern hemisphere will get repeated in southern hemisphere. Think back to your 4 different classifications. Troposphere, the layer in which we live, the layer where there is mixing of atmosphere. So tropopause. Okay. Think back to climate discussions, just reflecting. Based on your latitudinal relationship with temperature, equatorial region has highest temperature because the Earth's insolation is fairly concentrated directly. Once you go to polar region, there is more and more low inclination, so temperature is less. High temperature near equator, low temperature near polar region. This you fairly know, isn't it? Look at this. Now we're going to apply the concept and try to understand atmospheric pressure. This is my atmosphere. And Hadley is proposing this idea. Listen very carefully. There is a fundamental principle in climatology. We'll repeat it n number of times. Surface temperature influences air temperature. Let me write it here itself. Surface temperature influences air temperature. Surface is going to be hot, air will become hot. Surface is going to be cold, air is going to become cold. Common sense. Listen carefully. Equatorial region, direct insolation, high amount of energy. Surface temperature is hot, air temperature becomes hot, which means air has more energy. If I have more energy, air will rise up vertically. Air moves up. So this is what George Hadley says. Fairly reasonable. Okay. When air rises up, you create what pressure zone? Low pressure. Someone's waking up. Low pressure. And he says there is a low pressure belt getting created. Now, the word belt is new. He says it can be anywhere in the equator. You can be in Africa, possibly the Central African Republic. You can be in South America. Africa is right here. You can be in South America, Brazil's Amazon forest, or it can be in Indonesian forest. The point is, everywhere you go in the equatorial region, you will be experiencing a uniform low pressure region. That is what he calls as low pressure belts. Equator. Fairly good, reasonable. Come back to the polar region. George Hadley says reverse condition. Surface temperature influences air temperature. Surface is cold. Surface is cold, air will be cold. Air is cold, air's energy is less, which means instead of rising up, air will settle down. Correct? Once air settles down, someone sits down in an area, high pressure. So in the polar region, you create a high pressure belt. Okay, high pressure belts, low pressure belts. Makes sense. So air rises over equator, goes to the polar region, settles over polar region, don't draw the arrow mark inside the earth, comes back to equator. Got the idea? So he says, listen carefully, this diagram right here, he says, he's connecting, he says, sir, air rises up till tropopause. Air cannot penetrate and move beyond the tropopause. So after hitting tropopause, it diverges in both directions. Is it clear? Both directions. So it keeps moving, finishes it till the polar region, settles over polar region, wind blows from high pressure to low pressure and completes the entire cycle. George Hadley proposed a model based severely on temperature that due to high temperature in equator and due to low temperature in polar region, there is a low pressure belt and a high pressure belt. Air rises. See, this arrow mark I've drawn is a trop layer, tropopause. Okay, this one, tropopause, close to the blue color line. This surface level, the yellow color one, this is surface. You get it? So this is George Hadley's model, single cell model. Single cell model, one of the pioneering models in meteorology. Is it clear? Single cell model. First time a proposal is coming, and yes, it was accepted. He says that this is the reason for the wind. You see, the winds come from polar region to equatorial region. So if we study them, we can navigate really well. Switching the idea. Good. Very good. Is it clear? Once you've taken down and understood, use the word finished. Basic model, single cell model by George Hadley, the first pioneer who gave the model. Thank you. Now we're going to look at what happened. See, this model is fairly good, but the model didn't explain everything. The model had a flaw. Okay. What flaw, if you think about it? Think back to the wind movement again. Wind is governed by three forces: pressure gradient force, frictional force, Coriolis force. This would properly work if there is absence of Coriolis force, but Earth is rotating. Once Earth rotates, then you bring Coriolis force into calculation. At the same time, Earth is composed of several mountains, plateaus. Friction will be there. So frictional force and Coriolis force will introduce modifications. So what modifications do they introduce and what exactly happened? They decided to discard the model. But if you're throwing away this model, you need to go for a better one. So for that, I'm going to take you to physics and chemistry. Listen. Let me run down faster. This is an atomic model. This model was given by J.J. Thomson. J.J. Thomson discovered electrons. For discovery of electrons, he was awarded Nobel Prize in the year 1910. This atomic model was changed completely to this model, which we know as the present atomic model. The model was given by Ernst Rutherford. Ernst Rutherford. See, that's the beauty of science. In the first model, he said there are negatively charged electrons which are embedded into a positively charged sphere, like how seeds are embedded in a watermelon. Plum pudding model, you would have learned, right? So a plum pudding model was changed to Ernst Rutherford's model, whose atomic model, the orbit model, was totally different from convention. See, point you need to understand is models can be changed in science only if you have proper proof and theory. Rutherford should have shown proper proof and theory to support his new model. only then the old model will get discarded and new model they will adapt. Is it clear? So what did Rutherford do? Well, Rutherford did this gold foil experiment. I believe you remember. Simple. Over a thin gold foil, he would pass positively charged alpha particles, positively charged particles. Most of the particles will simply move without any disturbance. That is when he'll come to a conclusion that most of the atom is vacant. An extremely minor percentage, a fraction of them will get deflected back to the own position. That is when he will remember, yes, which means positive, alpha repels positive. So positive charge is concentrated in the center. He'll call it a nucleus. Then he said negative charges begin to orbit. Is it clear? So Rutherford was able to change the model because of the gold foil experiment. That is the foundation of science. Able to understand? See, single cell model was modified to a 3-cell model. Okay. My question is, I will explain 3-cell model now. My question is, what is geography's gold foil experiment? What did we do? What did we do? No, not me, not you. What do the geographers do? The single cell model, the 3-cell model. Destroy it and create new. What do? Something they did, else they can't change, no? Which means they found something. What do they find? A question, a simple question only asked. Come on, people. Make it faster. Rotation of the earth they found long back. Experiment. I will say myself. Oh. This is the problem, not learning geography for several years. Listen carefully. Physics lab you would have seen. Chemistry lab you would have seen. Biology lab you would have seen. Mechanical lab you would have seen. You ever seen geography lab anywhere? People, geography lab not there. How will you do experiment? Poi, sir, 2.5 kilograms of cumulonimbus clouds you give and analyze and give it back. So 750 meters rainbow, sir. Total internal reflection update, analyze and give. Geography, you can't experiment, people. Wherever things happen, you need to go and observe. See, geography, there is only 2 concepts. Observation, there is no experimentation, there is observation. And something more than observation, a geographer had to measure properly. See, one of the biggest good things which happened after Britain colonized the world, 1/3 of the world was colonized by them, is that every colony they had, they started establishing laboratories and universities for, of course, exploiting the colony. That is different. But laboratories are getting spread all over the world. By end of 19th century, you see, Africa is colonized, Asia is colonized even before that. So 1910 is the time they come with a 3-cell model. By that time, in many countries, many regions of the world, they have installed instruments. So by measuring pressure, by measuring atmospheric temperature in several parts of the world, they were able to get large amount of data. This was not there 100 years earlier. So this model comes around the time of World War I, the 3-cylinder model. Now, always remember, the model will be designed based on the experiment. Experiment data geographers got. So for the data only they decided the model. Reverse is not possible. So they get the data. After getting the data, they draw the 3-cell model. Go to the 3-cell model now. Tricellular meridional circulation, the main topic. Tricellular meridional circulation. So we'll draw 3 diagrams. First diagram is this. We'll have a longitudinal diagram. Then we'll go for the vertical one. Okay. 0, 90. There are 2 fundamental things they accepted from George Hadley's model, which they said Hadley is right. What 2 things is right? See. First one, yes, tropo passes the vertical limit. Accepted. Number 2, surface temperature influences air temperature. Fundamentally right. They accept. Hadley, you are right. He is dead, by the way. High temperature, air is rising. Yes, very good. Okay, low pressure is created. Surface temperature influences air temperature. Surface temperature is cold. Air is cold. Air won't energy. Air is settling down. Very good. High pressure. But this is Hadley. But this is okay. But in between, there is complication due to Coriolis force and frictional force. See, the air which hits the tropopause will diverge to both northern and southern hemisphere. We'll track the one in the northern hemisphere. Same thing happens in south also. Listen, air moves down and air settles approximately around 30 degrees. Is it clear? 30 degrees. When air sits down, what do you get? High pressure. Listen, how did I get the 30 degree? To suit my measurement and suit my data. 30 is not chosen arbitrarily. Is it clear? So picture this simply. Air is settling down. Once air settles down, it can't penetrate the earth and go. You blow, it doesn't penetrate my hand. Air spreads over. So one segment spreads towards the equator, one segment spreads towards polar region. Wait, the cycle is not over. Listen. Air settling down in polar region is moving towards south. Both these two different wind systems are meeting approximately 60 degree. Again, why 60? Suiting my observation. Listen what happens. Listen what happens. Air is coming from there. That is the stupid guy chair. He's stupid because he doesn't have a brain. That's why he called him. Is it clear? Air coming from 30 degree. That is me. Now both of us are colliding. Is it clear? Colliding na, see, chair can't move to this side. I also can't move to the chair side. Both of us can't go downstairs also. Is it clear? What will happen finally is, after collision, air parcel can only rise. Convergence needs to rise. Don't ask me the question, is it clear? See, that is not possible. Air passes are colliding means several human beings this side, several human beings this side, several chairs this side, several chairs this side. Both of them are colliding, only possibilities you move up. Is it clear? So after moving up, listen, hit the surface, spreading out in both these directions. This is my tricellular circulation. The three cells namely are Hadley cell, Hadley, Hadley cell, Ferrel cell, Ferrel, Ferrel cell. Oh, I should have written that properly. Wait, space was not there. Write it this way. Ferrel cell and polar cell. Is it clear? Hadley cell, Ferrel cell and polar cell. See, listen, 30 degrees and 60 degrees, don't make a mistake when you draw them all. Two mistakes will come. First mistake, people will draw it very carelessly. Listen, here, this is the mistake. In front of me, they'll do. Don't do that. Draw sequentially. There is an arrow mark which goes in the opposite direction here. Please be very careful. That's first mistake. Second one, 30, 60, air is rising. Since air is rising, it is a low pressure belt. Normally what they'll do is, sir, between 30 and 60, 30 is at high temperature. High temperature, air will rise. Okay. So low pressure, 60, low temperature, air will rise, high pressure. Please understand. Please understand. Only 0 and 90 degrees, the principle of temperature comes true. 30 degree and 60 degree are pressure belts not governed by temperature alone. Here, due to domination of Coriolis and friction, the pressure value changes. It is always alternate. Low, high, low, high. Is it clear? Hadley cell, Ferrel cell, polar cell. Don't you make a mistake in this direction. Front learner, look at your notebook. Once you finish it, just use the word finished. We still haven't finished this. Like, there should be 2 to 3 more diagrams. Wait. I haven't even named the wind systems. I haven't named the pressure belts also. 15 to 20 minutes, the final diagram will be set. What about the temperature in 60 degree? The air passes will not have such energy. See, CIN 2066057. That's what I told you. See, air passes can be lifted up because of 4 reasons. Four possibilities are there how air can move up. Number 1, since you have asked the question, first is temperature. It's not there only because of temperature. Second one, I'll tell you. Second one is relief. Relief means if a mountain wind direction is there, mountain is present, mountain will force air to rise. Number 2. Number 3 is convergence. Convergence is convergence. Air passes meeting inside. So large number of air tries to move in. They can't move in either direction. This is the third method. Again, air will move up. Temperature, heating, move up. moves up, moves up. Fourth is called frontal wedging. See, front itself, I did not tell you the definition. So, this will happen in cyclonic systems, frontal wedging. Okay, so how does air move up? Here, air moves up because of the third method of movement, convergence, moving up. Not always with temperature. Is it clear? 2066057. So 4 methods air can vertically move up. High temperature. Number 2 is relief. Mountains can force them up. Number 3 is convergence. And number 4 is frontal wedging. Frontal wedging you'll see in cyclonic systems. 4 methods are there. All these 4 methods can contribute to rainfall. Okay. Now, we're going to draw it this way. Make it simpler. Okay. Listen, atmosphere. Draw along with me. High temperature and equator, air is going to rise. Correct? Low pressure, exactly at 0 degree. This is called as equatorial low pressure belts. It is called as equatorial because it is at equator, LP. That's it. Got it. Number 2, air is settling down. So high pressure, 90 degrees. 90, high pressure. Polar high pressure belts. Why polar? It's in the polar region. That's it. Listen, air moves up, settles approximately at 30. Correct? So air settles down 30 degrees. Subtropical high pressure belts. Subtropical. Get the meaning right. Sub means the surrounding area. News articles you're running like sub-Saharan Africa, Sahel region, away from Africa. Subtropical. Tropical is 23 and 23. You move away, subtropic. 30 is just north of 23. Okay. After settling down, completes the first one, Hadley cell, moves north. Same time, air settling down at 90 moves south. Both of them collide approximately at 60. Convergence leading to air vertically moving up. This is my 60. Sub-polar low pressure belts. Polar region is the coldest climate. My 75 degree north, 80 degree north. Subpolar slightly away from polar region. Okay, so this finishes my polar cell circulation and this finishes my ferrous cell circulation. Stay until the last, we'll see the animation. Much easier for you to remember. This is the vertical diagram and this should be more comfortable compared to the previous one. One more diagram is there which will finish the wind system. Pressure belts. Equatorial low, subtropical high, subpolar low, polar high. Next diagram we'll do winds. Once you're done, use the word finished. This is the foundation for climatology. Get this then. Tomorrow climatic regions will just flow like this. Very simple. Thank you. So moving further. See, how do I draw the diagram? See, listen. Wind system. I've seen seniors make mistake. I don't know why they make these errors. They'll be memorizing. Memorizing now wind system, trade wind, westerlies, polar easterlies, we're going to see right now. Those things are not, don't do. 15 seconds is enough. We'll see one step by step how to draw the wind systems. People listen. First, draw the hemisphere of your choice. Northern hemisphere, southern hemisphere. Step 1. Step 2, write the names of your pressure belts. Always start from equator. You shouldn't get confused. Equator, it is always low. So no confusion. Low, subtropical high, subpolar low, polar high. Step 2. Number 3, draw pressure gradient force. Okay, so we'll use one color for that. Pressure gradient force, maybe green. PGF. Think back. Wind blows from high pressure to low pressure. Listen. Wind blows from high pressure to low pressure. High pressure to low pressure. High pressure to low pressure. Step number 4. Find upward arrow and draw Coriolis force. Listen. Because Coriolis force only I've seen many people make mistake. Find upward arrow. Why upward arrow? Means upward arrow's right side and your right side will be same. Upward arrow looking at camera. You're looking at camera. Same thing. Upward arrow's right side. Draw Coriolis force. Correct? So right side. Downward arrow will be in opposite direction. Again, I'll tell you what mistake you will make. They'll draw this. report, they'll put this arrow mark. Ending la they'll put right. See, understand, wind and a bouncing ball, hit after hitting, then it will go right. Don't do that. Source region la draw right side. Is it clear? Don't make that error. So first, draw the hemisphere of your choice. Second one, draw the pressure system. Always start from equator. Low, high, low, high. Third one, pressure gradient force. Wind blows from high to low, high to low, high to low. Fourth one, find upward arrow, draw right side. So reverse law automatically be the opposite direction. And don't draw the arrow at the end. Draw from the source region. Finally, draw resultant. One batch they asked, what is resultant? The non-engineering students, listen here. Resultant means, see, if this is going to be one force I'm giving. Okay. If this is the force, I throw this pin, it will come and hit your face. Now, along with this force, let's say there is one more person and he's trying to push this pen towards this side, right side. Is it clear? Listen. So there is force 1 and there is force 2. Thing is, the pen can't completely go in the right side. Listen, if there is only force 1, this is my direction. There is only force 2, this is my direction. If both forces are acting together, it will force somewhere here, no? Somewhere in between. That is my resultant. I'll draw the resultant diagram. Resultant. Okay. Resultant will be in between the arrow marks. Arrow 1, arrow 2, in between the arrows. First resultant. The winds which flows between 0 and 30 degrees are called as trade winds. Trade winds. Okay. Number 2. Resultant. In between both of them, pressure gradient and Coriolis. The winds which move between 30 degree and 60 degrees and 60 degrees is called as westerlies. Clear? The wind which flows between 60 and 90 degrees in between the resultants is called polar easterlies. Polar easterlies. This is okay. Trade winds, westerlies, polar easterlies. You finished? Let me know now. Trade winds, westerlies, polar easterlies. There's nothing to get confused or make error here. 5 simple steps. Anywhere, any point of time, confusion is there, you should be in a position to draw. Don't ever memorize this. Step by step you go. See, winds are named always from the source region. It is called as westerlies because it flows from the west. Easterlies because they flow from the east. That's all. Called polar easterlies because it is in polar region. Why the name trade winds? Because the winds helped in trade in the Atlantic Ocean when you move from Africa and Europe towards the Americas. Okay, one more response, I think I'll proceed further. I have a small task for you. Good. Now, finished now? Take 2 minutes, not running away. Draw southern hemisphere. Southern hemisphere, draw the pressure block. I want the wind system now. 2 minutes exactly. Draw now. Draw. 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 If you're here now, I'll catch you. Not able to catch anyone. People escaped. You'll make one mistake. You should make the mistake. Let's see where you've done. I'll tell you now itself, don't make the error. Southern hemisphere, Coriolis force left side. Don't do right side. Southern hemisphere, it should be left side, Coriolis force. Okay, 45 seconds more. $15. Make error means I won't do anything because I can't do anything. That's all. Time out. Time out. Listen. People. First mistake, you know what you would have done? First mistake possibly started low pressure from here. Low pressure always from equator. Low, high. Step 1, step 2, both done. Step number 3, draw pressure gradient force. Pressure gradient force, wind blows from high pressure to low pressure. High to low. Step number 4, find upward arrow. Only difference, Coriolis force to the left side. Left side, upward arrow. Left side. Finally, draw result and that's all. Trade wind. 0 to 30. Trade wind. 30 to 60. Westerlies. You see that? Wind are blowing from western side to eastern side here also. Westerly. 30 to 60. And finally, 90 to 60, you have your polar easterlies. Okay. Have we done this correctly? Okay, we've done it correctly. Very good. Now we look at the animation. It'll be better now. Okay. Good. I'll give a few more seconds for you to copy this. Then I'll show the animation. Then I think we'll take doubts. And if we start with the next topic, we might overshoot time. So, a few more seconds. It's nothing to get confused here. Okay, direction. See, it takes time. Twice or thrice you draw it, you'll understand. The left side and right side, that you just need to get that in your head. Northern hemisphere right side, southern hemisphere left side. That's all. Trade winds, westerlies and polar easterlies. So see the animation right now, and after that we'll go to doubt clarification.
The last
So I'll maximize and play.
video showed that different parts of the Earth heat up differently, with the equator receiving more radiative heat from the sun than the poles. And the purpose of global circulation is to redistribute this heat. If the Earth did not rotate and was a simple landmass with no oceans, we would have a single circulatory cell in each hemisphere, where hotter air would rise at the equator and flow toward the poles. The air would sink as it cools and then return towards the equator. But the unequal distribution of land and ocean and the speed of the Earth's rotation make this circulation system of land and ocean and the speed of the Earth's rotation make this circulation system more complicated, giving us a three-cell pattern which exists in both the northern and southern hemispheres. The largest cells are the Hadley cells. At the equator, the warmer, less dense air rises. It rises to a height of about 18 kilometres and spreads out underneath the tropopause. The tropopause acts as a lid to the lowest part of our atmosphere, which contains all of our weather. The warm air spreads out towards the poles, gradually cooling and sinking as it moves, before descending to the surface and flowing back to the equator. The smallest cells are the polar cells. Cold, dense air descending in the polar regions flows at low levels to about 60 to 70 degrees north or south. As the air leaves the polar regions, it starts to warm and rise, returning to the poles at high levels. Between the Hadley and polar cells are the ferrule cells. Unlike the other cells, the ferrule cells are not driven by temperature. These cells flow in the opposite direction to the Hadley and polar cells, acting like a gear. These circulating cells not only transport heat from the equator to the poles, but also result in semi-permanent areas of high and low pressure.
There is one more section which will show you regarding your wind systems. I'll just show that and then we'll take the doubts. You're right here.
Okay. Winds at the surface are also subject to deflection from the Coriolis explosively as they are steered towards the UK. Winds at the surface are also subject to deflection from the Coriolis force. The surface flow of the Hadley cells form the persistent trade winds. As air flows towards the equator, it is deflected towards the west in both hemispheres, forming the northeast trade winds in the northern hemisphere and the southeast trade winds in the southern hemisphere. The persistence of these winds allowed sailing ships to cross the Atlantic and opened up trade routes between Europe and America, giving them their name. The surface wind in the ferrule cells would flow from a southerly direction in the northern hemisphere, but the Coriolis effect causes this wind to be deflected to the right, leading to the prevailing westerly and southwesterly winds often experienced over the UK. This setup is not unique to our planet. Jupiter also has circulation cells similar to those on Earth. A day on Jupiter lasts for about 9.5 hours, so it is rotating much more quickly than the Earth. The great size and fast rotation of this planet makes the Coriolis effect very strong. This splits the Jovian atmosphere into many circulation cells in each hemisphere, producing numerous alternating bands of rising and falling air and giving Jupiter a distinctly striped appearance.
I think that would have given you a better idea on what you've actually drawn in your notebook. So the final diagram would look something like this. Please understand there are totally 7 pressure belts in the world, not 8, because the pressure belt in the center is common to both the northern and southern hemispheres. So low, high, then you find your subtropical high, subpolar low, and polar high pressure belts. The wind systems include the trade winds, which converge toward the equator, then the westerlies, and finally the polar easterlies. See, if you have Gocheng Liang, please keep the book ready for tomorrow. Tomorrow we'll mostly be using that book because we need to look 4 climatic regions: equatorial, deserts, British climate, and Mediterranean climate. Okay, it'll be like once we go to climatic regions, you'll understand why we spent enough time here. Without it, it'll look odd. So tomorrow's lesson plan is this. We'll be finishing the next topic associated with this. It's called properties of pressure belt. After properties of pressure belt, I will be teaching you 4 climatic regions. So get your Gocheng Liang ready. I will be using the photographs here, no problem. But if you have the book, you can start learning easily. Okay. So that ends the session. I'll open the session for doubts. So those who have doubts can raise your hand, and I think he can enable for audio. We'll directly get it to audio. Thank you. So others can leave if you're fine. Okay. Bye. See you tomorrow. Doubts alone.
Hello, sir. Good evening.
Good evening. Good evening.
Sir, can you explain which books we need to study for the today classes, sir? Which chapters?
So today we finished. So fundamentals of physical geography. You can start from chapter 8, I think. 8 is structure and composition of atmosphere. This was the previous session. 9 will be insulation heat budget. Now, I think you need to skip 10. 11, water and atmosphere on top chapter will be there. This is the heading of the chapter. 3 pages. Here only clouds, dew and fog, all those topics will be. Okay. This is the fundamentals of physical geography. Fundamental of human geography. Please work on the first unit. First unit meaning forget first unit or second unit, I don't remember. Point is, forget the introduction. Introduction one chapter will be there. That is not needed. After introduction, regarding population, there will be a unit. Population characteristics. That unit you need to learn fully. Is it okay? Okay. Global atmospheric circulation. Tomorrow I'll finish. Then I'll tell you the chapter. Okay.
Sir, I have one more doubt. Okay, sir, I will ask it later on. Let the others continue.
Fine. Okay.
Good evening, sir.
Good evening, ma'am.
Sir, is there any link between ocean current and Coriolis force?
Simple answer is Coriolis force affects ocean currents also, because ocean currents travel very long distances. They can travel for thousands of kilometers. So when they move, they get deflected by Coriolis force and they take these turns. Yes, they are affected.
That's all, sir. Thank you, sir.
Sir, regarding the climate, you have told three things, sir. One is desert, another one is polar climate, and another one is an equatorial climate, Brazil. You mean to say that there the people density or the people population will be very low?
Yeah, exactly. Like these are harsh climate for us. See, either there'll be total absence of water or this is total absence of water deserts. Polar climate, water won't be there, only ice and glaciers. Agriculture is difficult. Equator is one extreme. Temperature is very high. Rainfall is also very high. So not ideal for agriculture. Things has to be at a certain moderate limit. You don't want extremes. These are extreme climatic conditions. That's why you don't find a very high population. There is one exception. Exception I will tell. One country which is in equatorial climate but still having high population is Indonesia. But again, Indonesia.
But I think Nigeria also.
Yeah.
I think Nigeria also follows the same. No? Nigeria also in the equatorial, almost an equatorial, or it's a sub-Saharan.
Okay, Nigeria is having a complex geography. That's why I didn't tell you about Nigeria. Nigeria, only southern part of Nigeria has water resources and is part of your equatorial climate. Northern part will come under savanna climate condition. So Nigeria has two different climatic regions. Same country, but double will be there.
Okay, sir.
Okay, so
regarding the clouds, okay. So regarding the clouds, you have told different types. You have told about this. There are only few points have been written, sir. That is enough for the exam, or do we need to refer the book for the clouds, different types?
See, there is in Gocheng Liang, there'll be one more chapter on clouds. But tomorrow, let me finish, and I don't remember the chapter number, else I would have told you now itself.
Okay, sir.
Okay, so GCL, he would have given more explanation also. So I'll get back to on chapter number tomorrow. Okay.
Okay, sir. Thank you.
Sure, sure. Next person.
Sir, why Indonesia is an exception, sir, for this harsh
Still,
climate?
still,
It's inspired.
I don't have an answer. I've actually tried to come across different explanations, but as far as I've researched, can't really say why. That's why it's an example, not an example. We need more study to really say why this problem.
Okay, sir. Thank you, sir.
I don't. If anything is there, you tell me. I think else we can close the session. Your call. Raise your hand if you have doubts. Like we'll enable audio. Doubts, not doubts from class. Summa don't raise. Will Chennai win? அதெல்லாம் தேவையில்ல. Chennai win, Chennai lose doesn't matter. Indian economy is down. That is more important. Class notes and NCRT is enough, or should we study topics from GC Leong? GC Leong is very important for exam. Climatic regions is essential. Yes, you should learn. I will tell you tomorrow, teach you tomorrow. See, part 2 alone you need to learn. I'll tell you the chapter numbers also tomorrow, don't worry. It is required. Class notes, NCRT and GC Leong. No change. So anything else, shall we close the session? Few more seconds. Okay, then I don't see any hand raised, so we'll close then. Okay, fine. We'll meet you tomorrow. Tomorrow we're finishing 4 climatic regions, and I believe we'll have enough time. If we have enough time, I'll take you to jet streams and tropical cyclones. Okay, take care. See you tomorrow. Bye.